Good morning, everyone. My name is Tim U. Gibson, and I will be serving as the designated federal officer for the U.S. EPA Science Advisory Committee on Chemicals, which we refer to as the SACC. For this meeting and in my role, I will be opening this public meeting, and I want to thank Dr. George Cobb for agreeing to serve as chair of the committee for this meeting. I also want to thank the members of the committee, ad hoc reviewers, and the public for attending this important meeting. We appreciate the time and effort of the committee members in preparing for this meeting, taking into account their busy schedules. Additionally, I want to thank the EPA's Office of Pollution Prevention and Toxics, which we refer to as OPPT, and to my colleagues at the Peer Review and Ethics Branch in EPA for their hard work in preparing for this important review of EPA's 2024 draft risk evaluation for formaldehyde. By way of background, the SACC is a federal advisory committee that provides independent scientific peer review and advice to the EPA on chemical-related issues regarding the impact of proposed regulatory actions on human health and the environment. The SACC provides advice and recommendations to EPA. Decision-making and implementation authority remains with the agency. The SACC is comprised of experts in toxicology, environmental risk assessment, exposure assessment, and related scientists. The expertise of these members is augmented by ad hoc reviewers who are temporary participants in the SACC activities, providing additional scientific expertise for the review of the draft risk evaluation for formaldehyde. As a DFO for this meeting, I serve as a liaison between the SACC and the agency. I am also responsible for ensuring provisions of the Federal Advisory Committee Act, FACA, are met. The Federal Advisory Committee Act of 1972 established a system that governs the creation, the operation, and termination of executive branch advisory committees. SACC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov listed in the meeting agenda. As the designated federal officer for this meeting, a critical responsibility is to work with appropriate agency officials to ensure that all appropriate ethics regulations are satisfied. In that capacity, committee members receive training on provisions of the federal conflict of interest laws and ethics and scientific integrity trainings. In addition, each participant has filed a standard government confidential financial disclosure report. Our deputy ethics official for the Office of Program Support and their team, in consultation with the Office of General Counsel, have reviewed these reports to ensure all ethics requirements are met. The SACC will review challenging scientific issues over the next 4 days. We have a very full agenda and meeting times are approximate. Thus, we may not keep to exact times as noted due to the discussions and public comments. As we move through the proceedings, as the discussions for one topic ends, we will move to the next agenda item. We strive to ensure adequate time for agency presentations, public comments, and committee deliberations. Copies of all EPA presentation materials, written public comments, and other documents related to this meeting are available in the public docket at regulations.gov. The docket number and the website are noted in the meeting agenda. For this meeting, there are so far 90 registered attendees, 39 of which are registered to give oral comments. Registration to attend this meeting is open until the last day of the meeting. Members of the committee and the ad hoc reviewers are encouraged to fully consider all written and oral public comments submitted for this meeting. We dedicated adequate time for the agency presentations, public comments, and peer reviewers to discuss their questions. For members of the press, EPA media relations staffs are available to answer your questions about this meeting. Please address all questions to press@epa.gov. At the conclusion of the meeting, the SACC will prepare a report as a response to the questions posed by the agency, the background materials, presentations, and public comments. The final report also serves as the meeting minutes. We anticipate the final report and meeting minutes will be completed approximately 60 days after the meeting is concluded. Again, I wish to thank the committee, ad hoc peer reviewers, and the public for your participation. I am looking forward to both a challenging and interesting discussion over the next 3 days. I now turn the meeting over to our esteemed chair, Dr. George Cobb. Dr. Cobb?
Thank you, Ms. Gibson. And I'd like to welcome everyone to our meeting today, especially those from the public who are in attendance. We just heard the number. That's a large number of public attendees who are interested in this topic. I'd also like to commend the EPA on their diligence in developing this risk evaluation. This assemblage of documents represents a tremendous amount of work by the EPA staff, and I certainly appreciate that. I'd also like to thank the Science Advisory Committee for Chemicals, both the full members and the ad hoc members, for the extensive work that has gone into reviewing these documents in the short time frame that we had, and that put some pressure on the committee. That I appreciate your work there. Having said those things, I would like to start off by saying, even with all of the great work EPA's done, there's several omissions in this risk evaluation that will need to be addressed, and some of these are holdovers from concerns that have been raised in previous evaluations. Things seem to be getting better in some places, but maybe not in all places. And I hope our discussions today can help navigate towards a more thorough and robust evaluation. So with that, I would like to ask the individual members to introduce themselves. And we have one member who is absent for travel today, so we will begin with Dr. Baker.
Hi, I'm Marissa Baker. I'm an assistant professor at the University of Washington in Seattle, Washington.
And Dr. Chason?
Good morning. My name is Dr. Chris Chason. Until recently, I retired, but I was director of the Lifeline Group. I'm a toxicologist with a focus on exposure assessment and modeling, especially for exposure and risk and aggregate risk. Thank you.
Dr. Ike?
Good morning. My name is Stephanie Ike. I'm an assistant professor at Emory University in the Department of Environmental Health in Atlanta, Georgia.
Dr. Fox?
Good morning, Mary Fox. I'm an assistant practice professor of health policy and management and environmental health and engineering at the Johns Hopkins Bloomberg School of Public Health in Baltimore, Maryland.
Dr. Graham?
Hello, I'm Cynthia Graham. I am an independent toxicology consultant.
Dr. Heiger-Bernays?
Hi, I'm Wendy Heiger-Bernays. I'm a clinical professor of environmental health at the Boston University School of Public Health.
Dr. Merced Nieves.
Good morning. My name is Francesca Merced Nieves. I'm an assistant professor at the Departments of Public Health and Environmental Medicine and Climate Science at Icahn School of Medicine at Mount Sinai in New York City.
Dr. Ottinger.
Good morning. I'm Marianne Ottinger. I'm a professor emeritus at the University of Houston and an endocrinologist, neuroendocrinologist, and ecotoxicologist in my areas of expertise.
Dr. Prisbilla.
Good morning. I'm an environmental health scientist with the Agency for Toxic Substance and Disease Registry. I have my expertise is in human health risk assessment. Thank you.
Dr. Reif.
Hi, I'm David Reif. I'm chief of the predictive toxicology branch at the National Institute of Environmental Health Sciences, and my expertise is in computational toxicology and bioinformatics and genetics.
Dr. Rubin.
Good morning, Rainbow Rubin, Director of Science at Breast Cancer Prevention Partners and affiliate with University of California, Berkeley Environmental Health Sciences Department. And my expertise is in environmental health and exposure assessment among sensitive subgroups in environmental epidemiology.
Dr. Rumpler. Dr. Rumpler. Okay, we'll go on. Dr. Voorhees.
Hi, I'm Charles Voorhees. I'm professor of neuroscience at the University of Cincinnati and Cincinnati Children's Hospital in the Division of Neurology, and I do work in both neurotoxicology and neuroscience.
Great. Mr. Wright. I know we had Mike on a minute ago. Okay, we'll move forward. Dr. Brycey.
Yes, good morning. I'm Patrick Brycey. I'm an emeritus professor at the Johns Hopkins Bloomberg School of Public Health. And my expertise is in exposure assessment.
Dr. Henneman.
Morning, Lucas Henneman, assistant professor at George Mason University in Fairfax, Virginia. My expertise is in ambient air pollution exposure.
Dr. Caden.
Good morning. My name is Deborah Caden. I'm a principal consultant at Ramboll, and my expertise is in toxicology, risk assessment, and genetic toxicology.
Dr. Kelly.
Morning, I'm Anita Kelly. I'm a professor at Auburn University, and my expertise is actually aquatic toxicology as it relates to aquaculture.
Dr. Kim.
Good morning, I'm Sang-Tae Kim. I'm a chemist and toxicologist at Ashland Specialty Chemicals. Thank you.
Dr. Landis.
Hi, I'm Wayne Landis, a research professor emeritus at Western Washington University. My specialty is ecological risk assessment.
Dr. McClellan. Yeah, we had him earlier. Dr. McClellan.
Yes, this is Dr. McClellan. Can you hear me?
Yes, we can.
Yes, I'm Roger McClellan, an independent advisor in inhalation toxicology and risk analysis. I previously served as a lead official at the Lovelace Inhalation Toxicology Research Institute. And from 1988 to 1999, I was the CEO and president of the Chemical Industry Institute of Toxicology, where a substantial amount of research was done on formaldehyde. I'm also the editor of Critical Reviews in Toxicology. I look forward to 4 days of stimulating conversation.
Thank you. Dr. Strickland.
Hello,
This is Judy Strickland. I'm a board certified toxicologist, recently retired, who specialized in alternative methods for human health hazard assessment.
Thank you. Dr. Sweeney.
Hello, I'm Lisa Sweeney. I am a risk assessment toxicologist for UES in Dayton, Ohio. And I'm board certified toxicologist and a certified hazardous materials manager. I'm really looking forward to the presentations and discussions.
Dr. Wolf.
Doug Wolf, I'm now a retired private citizen, independent scientist with a training in veterinary pathology and expertise in toxicology, toxicologic pathology, and carcinogenesis.
And Dr. Zhang. Dr. Zhang.
Hi. Can you hear me okay?
Yes, we can.
Yeah, okay. This is Lopin Zhang. I'm a professor emeritus from University of California at Berkeley at School of Public Health. I'm the toxicologist and specialize chemically exposure-induced carcinogenesis. Thank you.
Thank you. And sorry, I got your name a little wrong. I'll endeavor to do better next time. Let's go back up. We missed Dr. Rumpler. Has he joined? Okay, and I see Mr. Wright. You joined, Mike?
Yeah, good morning. I was actually here before. I was trying to unmute my microphone and my computer was not responding. My name is Michael Wright. I'm the retired Director of Health, Safety, and Environment for the United Steelworkers Union, which, despite our name, represents the majority of unionized workers in both the chemical making and the chemical using industries. And my expertise is in occupational exposure.
Thank you. And I realized that I actually missed Dr. Barakal.
Yes, I am Veronica Berrojan. I'm a professor in the Department of Statistics at University of California, Irvine. My expertise is in spatial and environmental statistics, and with particular focus on developing models for ambient air exposure assessment.
Great. And I apologize for missing you. There's the way this spreadsheet I'm reading from is set up. You're on the same line with a heading, so my eyes didn't see that. Okay, so thanks. It looks like we have almost everyone here today, so that's really good, and I appreciate everyone being here today. So let me get to our agenda now. So at this point, it's time for us to move into the presentations by the EPA. And the first presentation will be by Dr. Reeves, who's going to give us an introduction and a welcome. And she is the director of the Office of Pollution Prevention. So Dr. Reeves, you have the floor.
Hi, good morning. Can you hear me?
Can.
Wonderful. Thank you. And my name is Dr. Alyssa Reeves. For those that don't know me, I'm the director of the Office of Pollution Prevention and Toxics, or OPPT, here within EPA's Office of Chemical Safety and Pollution Prevention. Although I'm new to the Office of OPPT, I'm not new to risk assessment or risk management. My background is in environmental toxicology, and I have over 20 years of experience in human health risk assessment and risk management from my time in the Office of Pesticide Programs, a sister office to where I am now. It's been an honor and a pleasure to move over to the Office of OPPT at a time that is critical to the development of our chemical safety program and the implementation of amended TSCA. This is my first SACC meeting, and I'd like to kick things off by thanking you for giving your time and expertise to this important effort. Sound science underpins all of our chemical risk evaluations, and we use those as the basis to write rules to protect communities from dangerous chemicals. And peer review is an important part of our risk evaluation process. Your feedback helps us determine if we're on the right track, if we need to shift course, and if we need to consider things we hadn't thought of before. Ultimately, your feedback makes our risk evaluation stronger and more robust. I know there's a lot of material to evaluate for this peer review. Thank you for the work that you've done up to this point to prepare for this meeting and for all the additional work you'll do after this meeting to develop the report. We are looking forward to your input and advice that you'll be bringing and providing throughout the next 4 days. I also want to thank Tamu Gibson, the designated federal official, and the staff in peer review and ethics branch for organizing this meeting. I also want to extend my gratitude to the formaldehyde EPA team who has worked so diligently to prepare the draft risk evaluation for formaldehyde and to prepare for the SACC meeting. I'm very proud of the work that this team has done, considering it's such a complex risk evaluation. I also want to thank the public for participating in this process through oral and written comments. Your feedback is also important in this process, especially since any regulations or protections that may come from our risk evaluation might directly impact many of you. I also understand that many people are interested in the formaldehyde risk evaluation, but I would like to remind everyone that we're in the draft phase of our process. Please understand that we've made no decisions at this point. This is a very challenging chemical with a complex hazard profile and exposures from many sources, including some that are natural. Many sources of formaldehyde are not regulated under TSCA, but instead by other offices within the EPA, as well as by other government agencies, such as the Federal Drug Administration. This week's meeting is about our draft risk assessment under TSCA. We would like to keep the scope of these discussions on the scientific issues related to the hazard and exposure assessments and risk characterization that are within the bounds of TSCA. Please also understand that this is not an academic research project. Our current plan is to finalize the formaldehyde risk evaluation by December of this year. We need specific advice that will help us further develop and refine our draft risk assessment using data and methods that are available and validated now. We welcome input on research, model development, and data collection that could support risk evaluations for other chemicals in the future, but please recognize new research will not be available in time for this formaldehyde risk evaluation. As I said in the beginning, it's crucial for us to use the best available science in our assessments, and I believe transparency and collaboration are key to achieving these goals. And your work on this peer review will help ensure that we're effectively accomplishing our mission to protect human health and the environment. There's a full agenda today, and you'll be hearing a series of presentations from my team on various aspects of the draft risk evaluation for formaldehyde. So with that, I'll close here. Again, thank you, and we're looking forward to a productive meeting. Tamu, I think I'll pass it to you.
Thank you for that, Dr. Reeves. So we had you for introduction and welcome, and then some further remarks. Has you covered all of those?
Yeah, I think I covered all of those. Sorry, I may have done it all together.
It's all good. That's perfectly fine. So then thank you for that. And I think at this point we'll move on into the initial presentations by I apologize. Is it Dr. Bulhati?
Hi, yes. Good morning and welcome. My name is Rochelle Bahati. I am a branch supervisor in the Existing Chemicals Risk Assessment Division within the U.S. Environmental Protection Agency's Office of Chemical Safety and Pollution Prevention. We are responsible for conducting risk evaluations for existing chemicals under the Toxic Substances Control Act. I supervise much of the work that you will hear about today, including the completion of the 2024 draft risk evaluation for formaldehyde. My team and I prepared a series of presentations to provide you with a summary of several novel aspects of the formaldehyde risk evaluation that are the focus of our charge to the panel. My colleagues and I want to thank you for joining us today and your willingness to offer your scientific expertise to the US EPA by serving on this panel. The feedback that you provide as part of the Science Advisory Committee on Chemicals is instrumental in how we move forward with advancing risk evaluation methods under the Toxic Substances Control Act. We look forward to receiving your feedback on the charge. To get us started, I'm going to provide you with a high-level overview of TSCA and the work we do in the Existing Chemicals Risk Assessment Division before we jump into formaldehyde. Next slide. Next slide. Yep, perfect. The Toxic Substances Control Act, or TSCA, of 1976 provides the US EPA with the authority to require reporting, record-keeping, and testing requirements and restrictions relating to chemical substances and/or mixtures. TSCA was amended and updated in 2016 by the Frank R. Lautenberg Chemical Safety for the 21st Century Act. The update included standards for chemical risk determinations. Specifically, Section 6 permits assessment and reassessment and regulation of chemicals that are already permitted to be manufactured and used in the United States to ensure ongoing safety. We call these chemicals existing chemicals. For existing chemicals, the US EPA must determine that the continued use is not likely to present unreasonable risks to human health or the environment, including potentially exposed or susceptible subpopulations. Next slide, please. To this end, the US EPA develops chemical risk evaluations. The purpose of a risk evaluation is to determine whether a chemical substance does or does not present an unreasonable risk to health or the environment under the conditions of use. Conditions of use are the circumstances under which a chemical substance is intended, known, or reasonably foreseen to be manufactured, processed, distributed in commerce, used, or disposed of. Examples of conditions of use include manufacturing, processing, and consumer use as in car products and craft supplies. The risk evaluation is the primary science support document that the US EPA uses to make a risk determination, and if we must issue regulations to address unreasonable risk identified as part of the risk evaluation, the risk evaluation informs risk management approaches to resolve the unreasonable risks. Next slide, please. The TSCA amendments mandate that the agency evaluate existing chemicals. This comes with clear and enforceable deadlines. In addition, the agency must use the best available science using reasonably available information and make decisions based on the weight of scientific evidence. Chemical evaluations must be risk-based and not consider costs and other non-risk factors in its evaluation. And as I previously mentioned, risk evaluations must also consider risks to potentially exposed and susceptible subpopulations. For those identified unreasonable risks, said risks must be addressed. This means conditions of use may be modified or eliminated, or other regulating actions such as do not release may be implemented. Next slide, please. As mentioned, TSCA provides science standards by which the US EPA must evaluate existing chemicals. These include using the best available science that is reasonably available. We need to use the data that are consistent with the intended use, that is regulation of chemicals under TSCA. Therefore, the data needs to be useful for our purpose and relevant to the decision. Our risk evaluations are not research papers. They are regulatory documents with very defined purpose and timelines. We must use the information we have available at the time we are completing the risk evaluation. Any information we receive past the defined point in time can help us in future risk evaluations or method development. We use the data that are at our fingertips. Next slide, please. To meet the law's requirement to base decisions and TSCA risk evaluations on the weight of scientific evidence, EPA relies on established agency guidance documents which provide consistency and formality to a process that looks to integrate multiple and often heterogenic lines of evidence. The weight of scientific evidence assessment is based on the strengths, limitation, and interpretation of data available, information across multiple lines of evidence, and how these different lines of evidence may or may not fit together when drawing conclusions. The weight of scientific evidence assessment requires multiple lines of evidence from scientifically relevant, published, or publicly available studies in the peer-reviewed scientific journals, studies conducted in accordance with the Organization for Economic Cooperative Development, commonly referred to as OECD, or EPA guidelines, gray literature, or any other studies, scientific information, or lines of evidence that are sufficient quality, relevance, reliability, are evaluated across studies and endpoints into the overall assessment. The weight of scientific evidence is a fundamental aspect of our risk evaluations. EPA has provided a summary of weight of scientific evidence narrative or characterization to accompany a detailed analysis to transparently describe the conclusions, as well as explain the selection of the studies or effects used as the main lines of evidence and relevant basis for conclusions. Next slide, please. As part of the TSCA risk evaluation process, assessors consider the conditions of use in the context of the relevant exposure source. For example, articles and products such as consumer goods or releases from industrial facilities, either to air, land, or water. Based on this information, the assessor considers a pathway of exposure, air, land, surface water, for example. From there, the assessor will estimate concentrations in the media, air, sediment, soil, or water, and how organisms will be exposed and the route by which they are exposed. Next slide. As mentioned, the risk evaluation is the primary science support document. As such, understanding the subject chemical is important in considering how the chemical will be managed in terms of any identified risk set the expectations for the risk evaluation. That is, our risk evaluations need to be fit for purpose. Spending a lot of time and effort to do analyses that cannot be used by risk managers or is not needed to support a decision is not an effective use of resources. I want to reiterate, our risk evaluations are not research papers. They are regulatory documents with a defined purpose. The US EPA must complete risk evaluations within 3 years. This time includes not only the completion of the risk evaluation, but it also includes peer review and multiple public comment periods, along with the completion of the risk determination. This means the actual time to complete the science aspects of the risk evaluation is short. As such, the methods, approaches you are being asked to review must be adequate to derive risk estimates sufficiently robust to support an unreasonable risk determination and subsequent rulemaking, as well as be feasible to complete within the necessary time. The development of an individual risk evaluation, as well as the overall risk evaluation process, is an incremental and iterative process. We learn from each risk evaluation and modify and further develop new assessment methods and approaches to improve TSCA risk evaluations moving forward. However, as mentioned, we must use information that we have available at the time we are completing the risk evaluation. Any information we receive past this defined point in time can help us in the future or with method development. Next slide. We use several processes to get feedback on our risk evaluations, as well as the methods we use to develop them. All are consistent with the US EPA's peer review handbook and include public comment periods and peer review as required under TSCA. We have several internal peer review mechanisms, including technical teams, committees, peer-to-peer reviews, as well as senior staff reviews. We often collaborate across offices within EPA, including with the Office of Pesticide Programs, the Office of Research and Development, the Office of Water, the Office of Air and Radiation. Similarly, we work with other government entities like the Occupational Safety and Health Administration and the National Institute for Occupational Safety and Health. Outside of government, we have several ways to seek external peer review. The SACC panel is an example. Other examples include contract and letter peer reviews. We may also use journal publication process to obtain review and feedback on approaches we are developing. We also engage with stakeholders to solicit feedback. One way this is done is through workshops. For example, we have convened a series of stakeholder workshops for input on various topics, including the ongoing workshop series devoted to improving occupational exposure assessments. Formaldehyde, in particular, is no exception. There has been substantial collaboration in review, including external peer reviews completed by the National Academy of Sciences and the Human Studies Review Board. Next slide. From these efforts, we can learn and implement better processes going forward in future risk evaluations. Feedback given by this SACC panel will aid the US EPA in deciding when and how to use modeling approaches to estimate potential exposure to chemicals, assist the agency in quickly identifying readily available data that's best utilized in our risk evaluations, define conditions when a specific model or evaluation strategy is best applied, and aid in further method development that can be utilized in currently ongoing or future risk evaluations. Before jumping into formaldehyde-specific topics, I want to pause and thank you for your attention. Next slide.
Thank you. So at this point, I'd like to see if there are any clarifying questions from the committee. Dr. Wolf.
Yeah, just real quick, thanks for that great overview, both of you, for the office. Just, do you have a definition of unreasonable risk? I was wondering how that's different from what's written into the legislation of no appreciable risk of harm, or do you consider those the same?
Hi, so we don't currently have a definition of unreasonable risk.
Was there someone else trying to speak?
So hi, I want to just recognize that the risk determination is out of scope for this meeting. And we're not asking any charge questions, and there's a lot of policy analysis goes into the risk determination that's outside of the science analysis.
Not sure what you're saying.
So Dr. Wolf's question had to do with the interpretation of the statutory language of what it means to have unreasonable risk. And we talk about unreasonable risk in the risk determination, not the risk assessment components.
I guess my question was really around no appreciable risk of harm versus unreasonable risk. Are they similar definitions then?
I don't think so. I don't think so. We don't make a distinction, at least the people in this room don't. There are no risk managers in our group right now.
Okay.
I want to move to remind everyone to state your name when you speak so that the transcriber can appropriately assign your comments to the individual. Thank you.
This is George Kopp. Thank you, Tim, for that. Sorry, I did not get us off to the best start here.
Hi,
Sorry, that Anna Lowett, OPPT Senior Science Advisor.
And it was Doug Wolf asking the question.
Are there other questions, comments?
This is Roger McClellan. Can you hear me? Hello?
Yes, we can hear you.
Yes. As an elected member of the National Academy of Medicine, I have followed the review of the 2022 document as well as a prior review of an earlier IRIS document, 2011, on formaldehyde, very closely. Indeed, as a National Academy of Medicine member, I was an internal reviewer of the 2011 document. As you are aware, the National Academy review raised a number of important issues. Because that document has a central role in the current SACC peer review, I'm compelled to ask the current status of the EPA's revision of the 2022 IRIS document. I think the EPA's response will be of keen interest to my fellow committee members and the public.
Hi, Rochelle Bahati, EPA. We are currently looking at the comments, our colleagues and working with our colleagues in ORD. It is my understanding, and I will get this in my next presentation when I get into the formaldehyde specific details, that the IRIS assessment will be finalized by the end of this year, but I can't speak for them definitively.
Thank you.
Dr.
Yes.
Landis, I see your hand is up.
Thank you, George. I'm Wayne Landis. My question is, without some clear definition of what risk actually means in this case, it's very difficult to evaluate the endpoints that are the subject of the various toxicity tests and the various kinds of assessments, both for the human health and the environment. And I was wondering if there was a better clarification of what specifically the term endpoint means. And the EPA definition is an entity and an attribute of that entity when it comes to ecological risk assessment. I did not see those things specifically mentioned in my reviews. And I was wondering if that was an oversight, intentional, or is not comport with the definition of risk in this study.
So, hi, Anna Lowett, Senior Science Advisor. I'll get it started and then I'll defer to Sean Shiflett on the eco part of the question. So if you look in our the charge questions that we're asking the panel, we're focused on data interpretation, use of models, the real meat of the science that goes into our analysis. And our expectation for the next few days is that we really talk about those things, the data analysis, interpretation of studies, methods, models, etc. And that interpretation of risk is quite challenging in this case. And so our request is that we stay on the science and not on the policy interpretation of what that means. So Sean, do you want to talk about the eco piece of that?
Actually, Melody Burnell, are you on the call?
Yep. Hi, Melody Burnell with EPA. Wayne, I'm not sure that I fully understood your question. We do have hazard endpoints in the environmental risk hazard module. Our charge question with respect to environmental risk is focused on the weight of scientific evidence for our immediate pathways.
So this is George Cobb. I think in maybe support of Dr. Landis's question, it's difficult to assess the adequacy of those data and approaches if we don't understand what risk criteria are being sought. Wayne, if I'm putting incorrect words in your mouth, you just speak up. But that's kind of what.
George, thank you very much for that. That's exactly what I mean. It's very hard to know what precision and accuracy is needed unless we have some idea of the target. And in fact, I've written that that's one of the first things you need to know is what do you care about? And that's a way of identifying what the targets are. And that is as much a science, that's as much a part of the science as the models and so forth. We need to know the accuracy and precision of the models and the tests to make sure that they hit the kinds of targets that aid decision makers in that process. And this is a very common thing in the kinds of risk assessment that I do and my colleagues that are members of like the Society for Risk Analysis. I mean, this is one of the key items to have a very clear idea of what the targets are in order to evaluate the information.
Thank you. Anna, did you want to make a comment?
Anna, that was me. I'm sorry. I appreciate what you asked. So I think that we're probably getting into the discussion, and we should maybe wait for the ECO presentation later, where you can see the presentation and ask more pointed questions, and some of that may actually get into the discussion of the charge questions. So I don't want to go too deep in this discussion. But there are some policy lines here that we want to make sure that we're not crossing, but we do acknowledge that there is a science component of evaluating the relationship between the data availability and the data needs and concepts like that. But I would ask that maybe we defer this to the presentation in a bit.
Thank you. That answered my question, and I'll wait for the further presentation.
Thank you, EPA, for the answer. Wayne, thank you, Dr. Landis, for the question. And now we have a question from Dr. Kim.
Yes, my question is also related to the unreasonable risk. If we cannot really define what is unreasonable risk, at least we have to clearly define what is acceptable or reasonable risk, whether it actually also includes foreseeable misuse conditions, particularly when we are dealing with the consumer exposure considerations. So if you look at formaldehyde, carcinogenicity is one endpoint, but sensitization and sensory irritation is another endpoint that is important endpoint. But if you look at the individual susceptibility, susceptibility to individual to sensory irritation and sensitization varies a lot. So in that regard, if you don't really establish what level of sensitization or irritation on the population is acceptable or not acceptable, it would create either we really set our threshold very low or very high. So I think in that regard, I think it's important for us, if we cannot establish unreasonable risk, I think we have to define what is acceptable or what is a reasonable risk in our assessment. That's my personal opinion. Thank you.
Good morning. This is Jeff Morris. I'm director of the EPA's Existing Chemicals Risk Assessment Division. So it's my team here that has done the assessment. I thank you for all the questions regarding unreasonable risk, and I'll try to do my best to help clarify. So it's true, under the law, we need to make a decision as to whether or not a chemical substance presents unreasonable risk under its conditions of use. There's no definition of unreasonable risk in the law or in our regulations, although in our regulations, we have described some of the factors that we consider when we use an assessment to support a determination of unreasonable risk. And those start with the traditional benchmarks, human and ecological, that we use to evaluate risk. And I know many of you who are familiar with cancer risk assessment, whether we look at 1 in a million or 1 in 10,000 additional cancers, that's an example of a benchmark. We also looked at other attributes such as severity of the endpoint, reversibility, the variability within a distribution in developing a risk estimate, our certainty or uncertainty that is sort of part and parcel of that risk evaluation. All those factors go into considering whether or not the risk estimates that we develop in our risk assessment support a determination of unreasonable risk. And it's really the assessment combined with the determination that makes a risk evaluation under TSCA. So what we're asking charger questions around now are the risk assessment documents that you have under your review. And I'll just say too that those who are familiar with the program recognize that the EPA under TSCA has sort of two different risk determinations. You have a may present determination, which really brings an existing chemical into the process for evaluation. Every chemical that ends up being prioritized as a high priority for evaluation has met that standard for may present a reasonable risk. The next step then is to evaluate the data, do the assessment to determine whether or not that chemical moves from may present to presents or does not present a reasonable risk. So what we're attempting to do in our assessment documents is use the, as was stated, the best available scientific information that's reasonably available to us to derive estimates, be they quantitative or qualitative, to support that determination. But that determination really is, as was stated, very much a policy/science policy decision that comes out of looking at the risk characterization. So I hope that that provides some additional clarity around the distinction between the risk assessment documents that we're asking the SACC to review and comment on, and the risk determination that we're then required to make based on those assessments to support that unreasonable risk determination. Thanks.
Thank you. This is George Cobb speaking. I do want to remind everyone on the committee and the EPA staff that when you're speaking, please do turn your camera on if possible, and that will allow folks to see who's speaking. And it also helps, I think it brings people to the top of everyone's screen, so you're not buried in the weeds of the multiple screens of people that we have here. So I do not see any additional hands raised for clarifying questions. So if there are no more questions, I believe we can now proceed to the presentation of the risk overview and risk assessments by that's Dr. Bohati again.
Hi, Rochelle Bohati with EPA. So let's jump into formaldehyde. In this presentation, I'm going to provide you with an overview of the formaldehyde history and risk assessment.
Can you please turn your camera on?
Yes. I think my camera is on.
Oh, okay. Now it is. Now
You
it
found,
is.
did you
You're
find
good.
me? Okay, perfect. All right, so at this point, I want to begin speaking to you about some of the unique properties of formaldehyde. Formaldehyde is a highly reactive gas that's ubiquitous in the indoor and outdoor environments. Formaldehyde naturally occurs as a product of combustion, a product of normal metabolism in the human body, and is formed through the decomposition of organic matter, that is, biogenic sources. Formaldehyde is also present without human activities. Biogenic sources, that is, natural sources such as trees, directly emit formaldehyde to the ambient outdoor air, or as I mentioned, decomposition of organic matter. Chemicals that are naturally found in the ambient air, as well as chemicals that are in the air from man-made sources, can also undergo chemical reactions in the air to form formaldehyde. And this is called secondary formation of formaldehyde. In addition, there are also human activities that result in the direct release of formaldehyde. Next slide. Formaldehyde was designated as a high priority substance for risk evaluation in December of 2019. The final scope of the risk evaluation for formaldehyde was published in August of 2020. The draft formaldehyde risk evaluation was released for public comment and external peer review by the SACC panel on Friday, March 15th, and the public comment period closed on May 14th. It should also be noted that our sister office, the Office of Pesticide Programs, released their draft risk evaluation for formaldehyde under the Federal Insecticide, Fungicide, and Rodenticide Act, or FIFRA, in April of this year. I will speak to the coordination and collaboration shortly when I describe various agency collaborations. The final risk evaluation for formaldehyde is expected in December of this year. As such, in your response to the charge, please be practical in what the agency can accomplish in the short term for formaldehyde and what can be accomplished over a longer period of time that might be useful for other risk evaluations. Next slide. So before we jump into the risk assessment, I want to make sure you understand what uses and sources of formaldehyde are not considered in our assessment. We do not consider smoking or combustion, such as forest fires, plastic products used for food storage and distribution, animal feed, forests, trees, wood chips, and pulp, drugs for fishery and hatcheries, and embalming or preservative uses from funeral homes or taxidermy. Next slide. So what is included? I have provided a list on this slide. Formaldehyde toxic conditions of use assessed in our risk evaluation include manufacturing, that's domestic and import, processing, that's adhesive, sealants, plastic, wood products, paint, soap, paper, industrial uses, oil and gas drilling, processing aids, paints, coatings, commercial use, floor coverings, foam seating, leather tanning, laundry, adhesives, and paints, consumer uses, floor coverings, fabrics, laundry, adhesives, paper, automotive care products, lawn and garden products, arts, crafts, and hobby materials. Distribution and commerce, and disposals. More information on the conditions of use can be found in document 12 of the risk evaluation, and then they will be reiterated in the relevant assessment documents. Next slide. As I mentioned, the OPPT has engaged in collaborations across the agency in its development of the TSCA draft risk evaluation for formaldehyde. Because formaldehyde was being assessed under both TSCA and FIFRA, the Office of Pesticide Programs, or OPP, and the Office of Pollution Prevention and Toxics, OPPT, it made sense to form a work group to harmonize. The primary focus was on harmonizing the human health hazard characterization with each other and with the Office of Research and Development's IRIS assessment. Again, since IRIS had already done a substantial amount of work on hazard characterization, it made sense to leverage their work and expertise. After all, we are one EPA. As such, both offices, OPP and OPPT, are relying on the ORD IRIS assessment for cancer and non-cancer effects for the inhalation route. In addition, OPP and OPPT coordinated with each other to derive hazard values not provided by the IRIS assessment. That is, values for oral, dermal, and acute inhalation routes. Oral and dermal hazard values will be based on the data derived from a systematic review conducted under TSCA, while the acute inhalation is based on human studies that were reviewed by the Human Studies Review Board, or HSRB. The offices are also coordinated on the fate and environmental hazard assessments. It made good sense to leverage resources when possible across offices within EPA. Next slide. As such, the draft risk evaluation for formaldehyde looks a bit different than prior risk evaluations. On this slide, I show the risk evaluation document map. I show you this figure to illustrate the different approach to developing the risk evaluation for formaldehyde compared to prior chemicals. Formaldehyde has multiple documents that make up the risk evaluation. In this modular approach, we have several discipline-specific technical support documents that feed into two risk assessments, the environmental risk assessment and the human health assessment. This approach is in response to SACC feedback on the need for a streamlined risk assessment. The risk assessment documents tell the risk assessment story, and that includes the risk characterization, while the details of all the analyses are provided in the technical support modules. This modular format worked especially well because some of the documents are co-authored across multiple offices, and those are highlighted in gray on this figure. As I mentioned, we collaborated with OPP on the development of 3 documents. Those are presented in the dark gray shaded boxes, and those are the chemistry fate and transport assessment, the environmental hazard assessment, and the human health hazard assessment. This structure allowed us to directly cite other assessments like the IRIS assessment. This assessment is shown at the bottom of the figure in light gray. In addition to being a useful format for collaboration, this format allowed for a staggered and targeted review process, resulting in a higher quality product. You should expect to see many more risk evaluations take on this format. But I also want to be transparent that we are in a transition phase and not all of our upcoming risk assessments will look this way, but it will be a gradual process and you will see more going forward. The draft risk evaluation for formaldehyde is made up of 60 plus documents. When you consider all the supplemental documents and support files, this is a lot. I show you this image to orient you to all the documents that we have made available to you and the public. At the end of this presentation, I have included a quick reference guide to the charge questions with links to all the documents you should need during this meeting. If you will see this figure in similar form throughout the series of presentations today. This will help us keep on track. We hope this is useful to you, and as we have tried to organize the documents around the charge themes and the modules. Also, my team references the charge questions and numbers with the respective technical support modules throughout the series of presentations. Hopefully we have cross-referenced sufficiently to make locating the relevant source documents easy. Next slide. Another aspect of the draft risk evaluation for formaldehyde that's a bit unique and also introduces some challenges is that aspects of the assessment have already been peer reviewed by expert panels. As previously mentioned, we are relying on the Office of Research and Development's IRIS assessment for cancer and non-cancer effects for the inhalation route. This has been reviewed by the National Academy of Science and Engineering and Medicine. The National Academy of Science is a premier private nonprofit organization that provides science-based advice on critical issues. EPA is currently considering the comments as part of this review, and the final IRIS assessment is expected to be published prior to or in coordination with the final TSCA risk evaluation. In addition, the Human Subjects Review Board has also reviewed individual studies relating to the acute inhalation. They've also considered the weight of evidence for the acute inhalation point of departure. HSRB also reviewed dermal studies that are considered in the draft risk evaluation for formaldehyde. Next slide. So this is the quick reference guide that I referred to earlier in my presentation. So you can see that we've listed the charge questions and the relevant documents for reference and the link to those documents on this and the next slide. I thank you again for your attention.
Thank you for that presentation. So are there any questions from the committee regarding the presentation that we just heard? I see Dr. Strickland's hand. Dr. Strickland, are you there? Maybe, yes, there you are.
Yes.
And turn your camera on too, if you can.
Hello, Judy Strickland. Sorry, I had trouble getting my camera on. But I was wondering if Dr. Bohati could tell us a little bit why those sources that were not included in the risk evaluation were not included. Just the rationale for that.
We can't hear you. I'm sorry, we can't hear you,
Sorry.
Dr. Bohati.
Hi, Dr. Rochelle Bohati with EPA. Can you provide me with some specific examples of what you think is missing?
Well, there was a slide that you showed that listed sources that were not to be included in this assessment, and it was some of them were occupational, like the use of formaldehyde and embalming, formalin in embalming and taxidermy. There were some other natural sources on there, like wood fires, and I don't remember what the other elements were, but I'm just wondering, what was the rationale for not including those?
Okay, Rochelle Bohati again, thank you for clarifying. So those are not considered conditions of use under TSCA. Specifically like the embalming or the taxidermy, that would fall under the pesticidal use. And so it would not be covered under TSCA. In terms of forest fires and other combustion source, again, those are sources that we wouldn't be able to regulate under TSCA.
Does that answer your question, Dr. Strickland? Okay, thank you. Now, Dr. Graham, Dr. Graham, I think was next. I see you, Dr. Kim.
Okay. Thank you. Rochelle Bohati, you had said, and I can't quote you exactly, but be aware of the timeline for completion of this risk evaluation and what can be accomplished in that timeline. I'm concerned that since each TSCA risk evaluation is important to many stakeholders, including the general population, shouldn't EPA be more concerned with an accurate evaluation rather than, staying within this timeline?
Hi, Anna Lovett, Senior Science Advisor. Thanks for the question. And it is a relevant and important question. So our Assistant Administrator, Michal Friedhoff, is committed to completing a number of risk evaluations, not just formaldehyde, but a number of them, and by December of this year. But, we're looking for your feedback. And if the feedback from the panel sends us in some directions that we did not anticipate, we'll be reassessing that if that's the way it works out. But our preference is to stay on schedule and to comply with the request of our assistant administrator. But we're looking for your feedback, and we'll have to make those choices on what things we do and what things we don't do, and what might help future risk evaluations and possibly not formaldehyde.
Thank you.
The next question was from Dr. Kim. I'm sorry, I was muted.
Yes, my question is in regards to what makes distinction between my question is related to human exposure assessment. So what makes a distinction between the consumer and indoor air? There are different sections of it.
We'll cover that later. Yeah. Hi, that's a really good question. This is Rochelle Bohati with EPA. I would like to defer answering that question until we get into the technical presentations, because there are some slides that are dedicated to specifically answering your question.
Is that okay, Dr. Kim?
Yes, thank you.
All right. So, Dr. Ottinger.
Hi, I seem to have a stop on starting my video.
Do not worry.
Oh, there, anyway. I just wanted to follow up on the non-TSCA covered elements such as pesticides. Is it fair enough that we are able to refer to those as potential other aspects for models, or how would it be most helpful to the agency for us to consider those aspects?
Hi, it's Anna Lowett. Elizabeth Donovan, if you're on, can you answer that, please?
Sure, I'm just trying to get my video to start here. Okay, hi, I'm Elizabeth Donovan. I am with the Antimicrobials Division in the Office of Pesticide Programs. So the pesticidal uses of FIFRA are, pesticidal uses of formaldehyde rather, which are covered under FIFRA, are also going under risk assessment at this time. And so OPP recently published our draft risk assessment for the formaldehyde uses covered under FIFRA on April 19th. So it's out for public comment right now. The other uses outside of FIFRA, there are some FDA uses and things like that for formaldehyde that are going to be evaluated under those for those agencies under those statutes. Does that answer that question?
Somewhat. That's fine. Let's leave it for now. And basically what I was asking was that for those of us that might have concerns in that area, if it's listed under the responses, then that is fair enough, I assume.
Yeah, and as was noted earlier, we did work together, OPP and OPPT, on aspects of the risk evaluation and risk assessment for formaldehyde. So we're sitting in, listening to the discussion, and we'll be considering this discussion as, as we work through our risk assessment process and OPP.
Okay, thank you.
So I'll jump in. This is George Cobb, just really quickly. And I've made these kinds of comments in the past. When you have those different offices looking at different aspects, it would be helpful in the preambles or somewhere in these documents to kind of summarize where that stands. At what stage are those assessments? What does the risk assessment currently say, or how much of it is included? That would be helpful for answering the kinds of questions that Dr. Attinger and frankly I have about that process. But that's simply a comment, not necessarily a question. Dr. Heiger-Bernays.
Well, I'll start talking, and then they'll maybe.
Heidi, we can barely, excuse me, Dr. Heiger-Bernays, we can barely hear you.
Dr. Cobb, you muted.
Okay.
I muted and unmuted and muted again.
Okay, I think
There she is.
I think I have it. I'm sorry about that. I want to thank Ms. Donovan for the response to Dr. Ottinger. I had the same question with regard to where this integration happens and whether there will be opportunity to, I think, answer questions that weren't explicitly asked. And I understand we're being asked to just stick to the questions. So I think that response gives us a little bit of opening to go into perhaps the FIFRA analysis as well, if there are important information or data. With regard to the statements, important statements about sticking to schedule, but yet making sure that the science is right, I would like to just have on the record that the time frame for going through all of these analyses and actually answering the charge questions has been extremely challenging. And I appreciate the amount of work that the EPA is doing and has done on this. But I think from my perspective, to be able to do the job that I'm tasked with doing, this was very, very difficult. And it's really a function of having the materials and the charge questions assigned in enough time to be able to answer them. And that's simply for the record. Thank you.
Thank you, Dr. Hager-Bernays. I think Mr. Wright had the next question.
Yes, I wonder if one of our EPA colleagues could been asked to start my video, but I'm having trouble doing it. So if it's there, I think that got it. I was hoping that one of our EPA colleagues could very briefly describe the remaining steps in the regulatory process once the risk evaluation is completed, and what your projected timeline is for that.
Hi, Rochelle Bohati here with EPA again. Sorry, it took me a minute to hop on and got to find all the right buttons. So after the risk evaluation is complete, we will go into the risk management phase. And that will happen next year.
And when do you expect that to be completed? By the end of the year, or?
We can't.
Yeah, we can't. I don't know the exact timing for that.
Okay. Fair enough. Thank you.
Okay, Dr. Young.
Yeah, I just want to echo with my SACC committee members just raised a question about the exposure out on the EPA list. So I just want to make I still feel like embalming or medical technicians who are really using high level of formaldehyde at the work is this is a group of workers highly exposed to formaldehyde. So I think of course I think the EPA was telling us that's a part in EFRA instead of in this our assigned charge question. But I really, really wish we could have seen that when we are review the current risk assessment documents. So this is one comment. Two, also I like to echo with who said about the timeline. I do really feel EPA scientists have done so much work for this part of the formaldehyde risk evaluation. As a SACC member, I really wish we had more time to carefully review everything EPA provided to us. And so far from the charge question we were assigned until today, we only have like 5 or 6 working days. This is really difficult, I think, for the members to trying to fully or deep, review all the documents. I wanted to put this on the record. Thank you.
So Anna Lower, I'll respond to the question about the embalming and the medical uses. So I understand the panel wants to look at formaldehyde broadly. I understand that. I think we all understand that. You know, looking at it broadly. However, this meeting is about the Toxic Substance Control Act and things regulated under TSCA. The risk evaluation we're producing is limited to those contexts of use regulated under TSCA. So that, you know, with respect to the individuals available to answer your questions, we will have some pesticide staff, but we don't have any charge questions about embalming or any of the pesticide uses. And we don't have any staff from FDA who can answer your questions. So just recognize that. And if the panel elects to include those things as part of the report, also understand that the staff at OPPT will be referring those comments to colleagues across the agency or to our federal partners. But the risk evaluation itself is unlikely to be responsive to those comments. I just need everyone to understand those things.
Okay. So, Dr. Caden.
Thank you, Deborah Caden, Ramble. I want to echo my co-committee members' comments about the lack of time. And this isn't just complaining that it's not enough time, but it's really also doing a disservice to the many, many, many pieces of information that are supposed to feed into this, including over 200 public comments that were made. And I know personally, I could not find time to read each and every one of those. So hopefully these will be captured as part of the 30, I think I heard, public presentations. But there's a lot of information to understand and feed into this. And then the second piece of this is we're working with a set of moving targets. And so we're tasked with, depending on documents which have not been finalized yet, some of which may have changed due to peer review documents. And so without knowing what the final documents say, it's really impossible for us to know exactly what to depend on other than the draft that's out there now. So you know, I want to reiterate that personally, I feel that I've been hamstrung by not having the time or final documents to review for this.
So thank you for that. I'm not seeing any more. This is George Cobb speaking. I'm not seeing any more hands raised. I do have kind of a question, but it might be one that the agency would like to defer to the conditions of use, and I can certainly understand that. And it does specifically go to why transportation that is actually part of commerce was not included in this assessment. For instance, any kind of vehicles, land, air, water, that are used in commerce that produce formaldehyde or formaldehyde precursors, why were those not assessed? And if you would like to address that in the conditions of use dialogue, that is, I understand them. Will not complain.
Hi, this is Rochelle Bahati with EPA. I'm going to take the opportunity to defer and we can check in with you later. Thank you.
That's kind of what I thought. And honestly, part of the reason I mentioned that was to give maybe a targeted heads up to those who were covering that charge question.
All right. Thank you.
Okay. So with that, I think we've cleared the history of the risk assessment, and now I think it's going into the hazard evaluation. So the formaldehyde human health hazard overview, I think is going to be provided by Dr. Wegman.
We can talk about it.
That's right. My name is Susanna Wegner, and I will be providing an overview of the human health hazard assessment. Next slide, please. So for reference, I'll be discussing elements of the human health hazard assessment, which is document number 11 in the docket. And I'll start with a reminder that OPPT and OPP worked together to develop the hazard assessment for formaldehyde and ensure consistency across our programs. I'll also remind you that where possible, the hazard assessment relies on information and analysis from the draft IRIS assessment. Next slide, please. I'll start with an overview of the human health hazard values that we identified, and then I'll spend a slide or two providing more detail on the basis for each value, with a focus on those that are the subject of specific church questions. Next slide, please. This is a high-level summary of the hazard values that OCSPP identified for formaldehyde and the basis for them. We'll discuss each in more detail in the coming slides, but a few general points to note here. Together with OPP, we've identified hazard values for inhalation, dermal, and oral exposures. We're relying on existing draft IRIS values for chronic inhalation, both for cancer and non-cancer effects. Where IRIS did not develop values, we've relied on information collected and reviewed through a fit-for-purpose systematic review process that applies standard approaches from OPP and OPPT. Formaldehyde is very reactive, and that's reflected in the fact that the inhalation hazard values are driven by sensory irritation and respiratory effects. Hazard values for dermal are based on dermal sensitization, and values for oral are based on GI, gastrointestinal effects. Next slide, please. As we've already said, many of these hazard values have already, through some form of peer review, the chronic inhalation IUR, the inhalation unit risk, and the reference concentration from the draft IRIS assessment have both been subject to NAS peer review. In addition, elements of the hazard characterization and dose response for acute inhalation and acute dermal hazard have been subject to HSRB review. For the current SACC review, the scope of the specific charge questions for each hazard value are tailored to complement those previous reviews by NASM and HSRB. In the next slides, we'll walk through each of the hazard values in more detail, starting with acute inhalation. Next slide, please. To derive an acute inhalation hazard value, OCSPP used information and analysis presented in the IRIS assessment as a starting point. While IRIS did not derive an acute hazard value, the draft IRIS assessment compiled and considered a large amount of information that is relevant to acute inhalation exposures. In addition, OCSPP complemented the information presented by IRIS with additional information collected through a fit-for-purpose systematic review process. The quantitative basis for the acute inhalation POD is sensory irritation reported in a set of controlled human exposure studies in healthy volunteers. These human exposure studies went through HSRB review to meet requirements for studies involving human subjects. HSRB also reviewed a draft weight of evidence for the set of sensory irritation data. In that draft, EPA had originally explored deriving a set of acute PODs for different durations. Because sensory irritation for formaldehyde is not expected to follow Haber's law, meaning the effect may not be particularly sensitive to duration of exposure, HSRB advised EPA to reconsider that approach. Based on that HSRB feedback, EPA revised our approach to derive a threshold concentration at which sensory irritation is not expected to occur without adjusting for duration. In the context of risk calculations, EPA generally applied that hazard value to assess risks from 15-minute peak concentrations. Because elements of this acute hazard inhalation value have already been subject to FACC peer review, the charge questions on acute inhalation are targeted to seek SACC input on revisions made following that review. Next slide, please. This acute inhalation POD is the subject of charge question 1.1, so I'll take you a little bit deeper into the basis for that value. EPA identified several human studies with relevance to sensory irritation, including both controlled exposures and observational epidemiology studies. For the purposes of identifying a threshold air concentration associated with immediate sensory irritation responses, OPP and OPPT focused on 4 key studies that evaluated shorter duration exposures. All of these studies evaluate effects following between 2 and 5 hours of controlled exposure to formaldehyde at continuous levels. In 2 of these studies, Lang and Mueller, the study design includes 15-minute peaks in exposure during that 4-hour exposure period to lower concentrations. HSRB reviewed each of these studies and agreed with EPA's assessment that they are scientifically sound and ethically conducted, and that each of these can support the weight of evidence, with the caveat that Anderson and Mojave should be limited to a qualitative consideration. EPA identified candidate PODs based on eye irritation effects for each of the 3 studies we considered quantitatively, and found that the effect levels across studies were relatively consistent. EPA selected a threshold POD of 0.5 ppm based on the no observed adverse effect concentration reported by Kool-Aid et al. Following 3 hours of continuous exposure. But that value is really supported by all of these co-critical studies. Next slide, please. We'll turn now to chronic inhalation. For chronic non-cancer inhalation effects, OCSPP relies on the hazard characterization and dose response analysis and the reference concentration derived in the draft IRIS assessment. The draft IRIS reference concentration is based on a suite of respiratory effects identified in several studies in people. It's based on a robust data set in humans, and the key and supporting studies that serve as the quantitative basis for the reference concentration focus on effects reported in children. As described in the draft IRIS assessment, the reference concentration is chosen to reflect an estimate of continuous inhalation exposure to the human population, including sensitive subgroups, that is likely to be without an appreciable risk of deleterious effects during a lifetime. In OCSPP, we don't use a reference concentration directly. We instead use an MOE approach, a margin of exposure approach. That means that to apply the reference concentration, OCSPP needed to disaggregate the IRIS reference concentration into a POD and corresponding uncertainty factors. OCSPP selected POD based on pulmonary function because this is the endpoint for which the underlying hazard value and uncertainty factors are numerically equivalent to using the overall reference concentration. That means that for risk assessment purposes, this POD is quantitatively equivalent to using the draft IRIS reference concentration value of 0.007 milligrams per meter cubed. Because the IRIS assessment and the reference concentration have already been subject to peer review by the NAS, charge questions on the chronic inhalation hazard value are focused on our application of the value in the context of TSCA and characterization of the strengths and uncertainties of the analysis. In the next few presentations today, we'll offer comparisons between the basis for this chronic inhalation hazard value and the scenarios and assumptions underlying our exposure estimates for each pathway. Note that this non-cancer inhalation value derived from the IRIS reference concentration is also the hazard basis for the draft occupational exposure level calculated in Appendix E of the Human Health Risk Assessment. For cancer hazard characterization and IUR derivation, OCSPP again relies on the extensive analysis already completed in the draft IRIS assessment. IRIS concluded that, quote, evidence demonstrates that formaldehyde inhalation causes nasopharyngeal cancer, sinonasal cancer, and myeloid leukemia in exposed humans, given appropriate exposure circumstances, based on robust evidence in people, end quote. However, for sinonasal cancer, EPA lacks sufficient dose response information to define any quantitative relationship. And for myeloid leukemia, IRIS derived an IUR, but has low confidence in the quantitative relationship between formaldehyde exposure and myeloid leukemia. Therefore, the IRIS IUR and the quantitative cancer risk estimates that OCSPP rely on are based on nasopharyngeal cancer alone. IRIS also concluded that a mutagenic mode of action contributes, at least in part, to nasopharyngeal cancer resulting from inhaled formaldehyde. Where exposure scenarios include early life stages, OCSPP is therefore applying an age-dependent adjustment factor to account for increased cancer risks associated with early life exposure to chemicals with a mutagenic mode of action. Because the IRIS assessment and the IUR have already been subject to peer review by the NAS, charge questions related to cancer hazard are focused on our application of the IUR value in the context of the TSCA risk evaluation. Similar to non-cancer, in the next few presentations, we'll offer comparisons between the basis for the IUR and the scenarios and assumptions underlying our exposure estimates for each pathway where we apply it. Next slide, please. For non-cancer dermal effects, OCSPP derived acute hazard values based on dermal sensitization. This analysis was informed by a combination of human, animal, and in vitro data identified through the systematic review process. EPA derived PODs based on elicitation in human patch test studies and PODs based on induction in animal and in vitro studies. The two PODs derived through different data streams each converge at essentially the same value once uncertainty factors are accounted for, which increases our confidence in our POD. EPA sought review from HSRB on the ethics and scientific validity of the two human patch test studies used in this analysis. EPA then used those human studies in combination with animal and in vitro evidence in support of the hazard characterization and dose response analysis. Therefore, the charge questions posed to the include comment on the selection of the POD, the weight of evidence narrative, and characterization of our confidence and uncertainty. Next slide, please. And again, because this is a newly derived hazard value, we'll take a slightly closer look at the basis for this value. Formaldehyde is a known dermal sensitizer. Sensitization is an immune response, and it occurs in two phases. In the induction phase, a sufficient level of exposure activates immune mechanisms that result in dermal sensitization. And in the elicitation phase, an individual who has previously been sensitized has an immune reaction in response to subsequent exposure. Generally, elicitation thresholds for already sensitized individuals are expected to be lower than the threshold required to initially induce sensitization. Human patch test studies measure elicitation response in sensitive individuals. It would be unethical to conduct human studies intended to induce sensitization in a person who was not previously sensitized. So while it obviously is ideal to have human data, that data is limited to the elicitation phase. Animal and in vitro studies can evaluate the induction phase. So EPA derived a set of PODs based on a combination of 4 studies that evaluate both induction and elicitation, including 2 human patch test studies evaluating elicitation in sensitive individuals, 1 LLNA study in mice, a local lymph node assay that evaluates induction in terms of an EC3 value, and 1 study that applied an in vitro battery to predict an EC3. EPA identified PODs based on elicitation in humans and based on induction in animals and in vitro that converge on essentially the same effect level once accounting for corresponding uncertainty factors. Next slide, please. For non-cancer oral effects, OCSPP-derived chronic and subchronic hazard values based on gastrointestinal effects reported in animal studies that we identified through systematic review. The oral database is much more limited than the robust human database of inhalation effects. There are inherent limitations in many of the available oral studies due to the reactivity of formaldehyde. That results in many of the studies being rated uninformative for dose response according to OPPT's predefined systematic review data quality metrics. However, we concluded that several of these studies still provide valuable quantitative information that can support derivation of hazard values, particularly when multiple studies are considered in combination. We are seeking SACC input on how we interpreted the available studies and integrated the information across studies. Ultimately, EPA has not identified exposure routes with sufficient quantitative information to assess exposure quantitatively. EPA has qualitatively considered oral exposure pathways, but in the absence of quantitative exposure information, EPA has not applied these oral hazard values to derive quantitative risk estimates for formaldehyde. Next slide, please. And again, because these are novel values, we'll take a closer look at the basis for the oral hazard values. We identified 3 core studies, one 28-day drinking water study in rats, and 2 2-year drinking water studies, also in rats. Taken together, the 3 drinking water studies demonstrate a consistent pattern of gastrointestinal effects at comparable dose levels. All 3 studies were evaluated through both OPP and OPPT data quality review processes. And while data quality review identified limitations in each of these studies, EPA concluded that the body of evidence across all 3 studies in combination increases the overall confidence in both the nature of the effects observed and the levels of formaldehyde exposure associated with those effects. All 3 studies contribute meaningful quantitative information for the weight of evidence and dose response, and EPA used the PODs identified in these studies to support identification of subchronic and chronic oral HEDs, human equivalent doses. Next slide, please. We'll end the discussion of hazard on this final point. EPA is seeking comment on the strengths and uncertainties associated with the use of chronic non-cancer POD from the draft IRIS assessment for evaluation of formaldehyde risks to workers, consumers, and general population exposures through indoor and outdoor air. As we'll discuss more in the next few presentations, the charge questions for each exposure pathway include questions on the application of chronic inhalation values from IRIS in the context of each of those particular TSCA analyses. So that concludes the summary of the hazard assessment, and I'm happy to pause here for any clarifying questions.
Thank you, Dr. Wegener. Let's see, I see Dr. Kim would like to start us off. Dr. Kim.
Yes, Asante Kim, I have a question in regards to acute non-cancer dermal effects. I find that the endpoint used was sensitization. But when you think about sensitization, the increased frequency or repeated use of a product or material will create an increased risk of inducing sensitization. So sensitization is not necessarily considered as acute exposure. It's more likely repeated exposure or subchronic or chronic exposure. So is there a specific reason that sensitization is being used as endpoint for addressing acute non-cancer dermal effect rather than sensory irritation, which is more considered to be an acute effect?
Hi, Dr. Kim, Anna Lowett. I'm going to try to respond, and then maybe Susanna can add to it if she chooses to. So from a risk assessment context, if you think about the adverse outcome pathway for sensitization, our goal is actually to prevent sensitization. So do we want to keep the levels that individuals, workers, for example, may be exposed to in the workplace? The goal here is to keep the levels below which you get the first exposure. And in that sense, we are trying to protect against that first single exposure event. That helps answer your question. So from the eyes of a risk assessor, we look at it from the adverse outcome pathway and are trying to prevent those later key events.
Okay, thank you.
Thank you. That's very helpful. Dr. Ottinger.
That was presentation was very helpful. I've got a couple of questions. One is the lifetime effects, the definition, meaning that specifically if, let's say, younger people like, children or even infants would be more sensitive or susceptible versus older individuals, how's that incorporated into the model?
This is Susanna Wegner. So I think you're asking about how we're comparing this in certain exposure scenarios,
right?
Effectively. So you will see more as we go through each of the exposure scenarios specifically. But when we talk about lifetime, we, in the context of our general population exposures, where we assume, an entire lifetime of exposure, we look at a 78-year lifetime of exposure and incorporate an age-dependent adjustment factor. But beyond, and then for other pathways, we focus on exposure scenario specific duration adjustments that, in some cases include children and in some cases do not.
So the objective is to have one number basically that would be applicable across age groups.
Are you one IUR?
Sorry, yeah. So let me try, Dr. So Anna Lowett, thanks for the question. And that's actually a really complex question you're asking.
I know.
And so that's why we're asking the question about the application of the IRIS numbers in all of the exposure pathways. When we get to each presentation, you'll see that as we go through the pathways in the presentation, each one has a parallel slide on how we do the comparison of the, let's say, the occupational pathway, for example, to those endpoints we're using, whether it's the cancer IUR or the other endpoints, to show how they do and don't match.
Right.
And that's actually why we're asking, what seems like we're asking the same question over and over again, because it's actually a very complex question, because occupational is one set of people, whereas maybe consumers may be a different set of people. And so there's no yes or no answer to your question. It's a very complex issue.
Yeah, and apologies, that's why I was asking it, because there's so many subtleties to it. The other question I had was having to do with, and again, I might not be using the right terminology, but thresholds that are considered safe, and how do we line up with OECD or EU regulatory, what they have in place.
So this is Susanna Wegner again.
I
maybe need some clarification. Are you referring to thresholds in the context of our acute inhalation hazard value, or in the context of like an occupational exposure level type thresholds?
And the answer, unfortunately, is yes. In other words, are we going towards a regulatory kind of scheme that would, arrive at a quote unquote safe threshold of exposure that's going to parallel, and here I'm talking about the oral effects, data, because that's only based on those 3 papers, that all have pretty high levels of exposure when they see effects. And I was surprised because I would think the potential regulatory threshold would be much lower. And that's why I was asking.
So the word safe, just to sort of get us back to the jargon, the word safe is really a policy laden question that gets at
sorry.
risk management. So within the
Okay.
bounds of what we're talking about today, you know, if you're asking about the oral specifically, I mean, I think we all acknowledge that the oral database for formaldehyde is not nearly as strong as the skin sensitization, which is fairly extensive, and the inhalation, which is a lot, right? But the other side of that coin is that, you know, you need enough data to answer the regulatory question. In the case of formaldehyde, you know, we're not aware of any meaningful oral exposure scenarios by which we would need a very precise number. And so you heard from Susanna a few minutes ago, we've derived a proposed value, but we're not actually using it in either the OPPT or the OPP risk assessment.
Right. Thank you. I really appreciate that. I was just thinking in terms of how that might line up with EU regulatory kinds of activities, and that's probably a very premature question. So I'll stop there. Thank you.
All right. Next question is from Dr. Caden.
Hi. I'm going to specifically ask about the statement that formaldehyde works in part through a mutagenic mode of action when causing cancer in the nasal region. I bring this up because I think that this is a key question. You can have a carcinogen, which is mutagenic, but that does not work through a mutagenic mode of action. And I'm wondering whether EPA updated their literature search specifically looking for new studies that address mutation and genotoxicity for formaldehyde. Because when I looked through the search terms, I didn't see search terms that would have picked up several papers that I think are key that were not picked up.
So Dr. Caden, that's a really important question, and thank you for that. When we get to those charge questions, you know, we're looking forward to, if we've missed some papers, we'd love to, you know, get a list from you of ones that we missed. We'd appreciate that. And as you've seen from the questions, the extent to which in our use of the IUR and risk characterization, specifically those risk assessment pathways that relate to children, the extent to which, you know, you have comments on the use of the ADAF as it relates to the formaldehyde mode of action. We're really looking forward to hearing those.
Thank you.
Thank you. Lots of questions coming in. It looks like Dr. Heiger Bernays is next.
Okay, Wendy Heiger Bernays, you can hear me? Yeah? Yes?
Yes, we can.
Yes.
Okay, great. Thank you. Thank you. Dr. Wegner, that was really a really thorough and very useful presentation. Thank you. I did have a question where you mentioned that you had responded to previous comments that the SACC had provided in the approach that you took for the acute non-cancer or the acute inhalation work. Would it be possible to get a copy of the previous SACC questions recommendations?
Hi, this is Susanna Wegner again. So I think you're referring to, for the acute inhalation POD, the FACA comments that we were responding to were actually not the SACC, but the Human Studies Review Board, HSRB. Okay. And that is available online, and I'm sure we can get the links to the SACC members.
All right, thank you so much. I have one other question. In the basis for the non-cancer oral with the 3 drinking water studies with better, what is your confidence in the, I would say, confidence in the derivation of the both the selection of the PODs and the total uncertainty factors that you apply.
In the oral studies?
Yeah, yeah.
I'm hesitating to speak in a way that is at all inconsistent with what we wrote in the document. I know that we described in the document our level of confidence. We described the underlying basis for, at the end of the section on the oral POD derivation, we present the oral POD and then we have a little discussion of our confidence and the sources of confidence and uncertainties. And I don't remember our exact phrasing there. I think generally there are, over the course of that entire narrative for the oral PODs, we talk about the strengths and uncertainties of the individual studies, as well as how we integrate the information across studies and we make a case somewhat carefully in our language that together the three studies increase our confidence that we're seeing consistent, the nature of the effect is consistent across studies and the level at which we see the effects is consistent across studies. We have confidence that we have arrived at a value that is meaningful, sufficient to actually derive a value. But I see Anna.
Yeah,
I see.
So, Anna, again, thanks for, so I guess in the context of the question about the oral POD, just a reminder, and I'll probably say it again later, I apologize in advance for being repetitive. We're not aware of any meaningful oral exposures for which we'll need to quantify oral. The underlying, the TSCA program and how to apply systematic review is still a learning, growing process. And the context of that question is really about data integration and realizing that the context of the TSCA program is that we often work in a space of data that's not ideal, data that maybe come directly from the literature using old studies as opposed to modern state-of-the-art studies that may have OECD guidelines, for example. And so, we're looking for your comments on the POD and how we've integrated the information, but the real purpose of that question is to help us learn how to integrate information that's less than ideal and put it together, because that's going to help us with future risk evaluations and how to tackle that exact same problem in the understanding of, in the space of systematic review, where the studies themselves may not be perfect, but when you look at them in totality and look at it from a weighted evidence point of view, we actually know more than we give ourselves credit for.
Okay, that's very helpful. But okay, I'll leave it at that. We got a lot of work to do. Thank you.
Okay, next question is from Dr. John. Maybe we can go to Dr. Henneman.
Sure, thanks. Oops, I can't start my video yet. This is Lucas Henneman. I'll keep trying. There we go. Thanks for that helpful presentation. This is really just a basic question. I'm wondering if you could provide a definition for hazard value, coming from the exposure side. I'm not as up on the terminology, and then how that differs from POD versus threshold, especially in this context. Thanks.
Yeah, this is Susanna Wegner. We have been using that term hazard value to speak generically to the pool of values that we're talking, because we have cancer inhalation unit risks, we have the non-cancer values. And generally, when we say hazard value, we're talking about the values that we then carry forward for our risk assessments. So whether it's a cancer slope factor or inhalation unit risk, or whether it's a non-cancer level of concentration or dose of some kind. It is the basis for the hazard component of the risk calculations. Does that help?
I think so. So they're sort of generic in that they can mean different things, whether it's like number of, additional risk per concentration, or I guess, like go ahead. Yeah.
I mean, I think we were not intending to use it as a term of art so much as just a way of referring broadly to either the IUR or, the non-cancer values that we then use in our risk calculations.
Hi, Anna Lloyd, I'll add a little bit onto that. So through the risk assessor's lens, we calculate metrics of risk. In this case, you're going to hear, you've heard from Susanna that we've used a margin of exposure approach for non-cancer. And in the cancer case, we're doing a linear extrapolation based on the draft IRIS assessment. But so what that means is that and maybe what we need to do is not to be language. A point of departure specifically is a point on a dose response curve. Normally, when we talk about the points of departure or PODs, it's in the reference to non-cancer risk assessments, or in other cases where we're doing a cancer assessment, a threshold, where you have a starting point and then you apply uncertainty factors to that starting point, which is a dose somewhere on the left end of the dose response curve. So we'll try to maybe be a touch more precise with our phrasing if that's helpful for you. Apologize for that.
That's right. Thanks.
All right. Thank you for that question and answer. Dr. Young.
Do you mean me?
Yes.
Okay. Yes, I just have a question just for EPA scientists to confirm. When you mentioned the IRIS, IOR, my question is that the first time? Is the first time EPA now apply for the IOI to the chemical risk evaluation? So I'm just wondering, I was not so sure if that's a first the chemical has been applied to IOI, or EPA has previously applied to different chemical, risk evaluation. So, but I think to me, this IOR, sorry, I did say IOI. IOR is pretty level to my knowledge for the risk assessment. So I just want to make sure. Can you explain to me a little bit about this IRIS IOR?
So I think you're asking, is this the first time that this particular IUR has been applied outside of IRIS? And the answer is yes, in that the IRIS assessment is still in a draft form and is currently being revised in response to the peer review process. And we are coordinating with our ORD colleagues so that we sort of understand where they're heading. So yes, it has not yet been applied because it is still draft, and they are finalizing their assessment as we will be finalizing ours in tandem. Does that help clarify?
Yeah. So then the following question, I think from our charged question, my understanding is this development and application of the IOR to apply for both lung cancer or cancer outcomes peer reviewed by the National Academy of Science and Engineering and the Medicine. So that document is specifically, if I understand it correctly, because I was really comparing your old charge question and the current charge question, and you made that a little changes. So I just want to make sure that peer reviewed by National Academy of Science and Engineering and Medicine is specifically for the IOI development and application. Is that the case, or is it for the whole the risk evaluation of formaldehyde?
We've actually, oops, sorry, Anna Lowett, I'll get my video back on. A little unclear by your question. Are you asking about the differences in questions between EPA's questions and the NAS questions that have been asked by ORD? Or are you asking about the changes that we made between our draft questions and the final draft question? So it was a little bit unclear.
Yeah, actually, thank you, Anna, for pointing that out. Actually, it's both. So I did look at the question. I was assigned 3.4, and you made that change, but in the tracked documents, we didn't see the change. But when I compare with the old one, it was a change for the specifically, I just give you an example, charge question 3.4. So that one, now say cancer IOI, that's a question for the cancer IOI, is okay, derivatives in the draft of IRIS assessment of formaldehyde. So it is for the IRIS assessment. So it's generally, right? So that was peer reviewed by NASEM. So
Yes.
that changes didn't showing. So, but I just, okay. So I want to just make sure that was the first peer reviewed US EPA, I think it's 2022 applied for the cancer IOR, right?
Yes.
So that's basically, yeah, basically my question, because I did see you add that into the 3.4 to make sure that documents was peer reviewed. So this is one of basically, yeah, what I'm.
So the answer to your question is yes. The NASEM has reviewed the draft ORD, Office of Research and Development, assessment of the draft reference concentration. So that would apply to the non-cancer and the cancer IUR. So the answer to that part of the question is yes. The other part of your question is that, yes, this will be the first time that those values are applied in a risk assessment that will ultimately lead to risk management. And so the question that we're asking is about that utility and understanding the strengths and uncertainties of the ORD analysis, the studies that they selected, and how that impacts risk characterization and our description of the risks that we might calculate. So the uncertainties and the strengths of the studies, the uncertainties and strengths of the calculations, the relevance of the population in the studies to the pathway, the population we're assessing. So for example, the IUR is developed from an occupational cohort, and then the question that you said you were referring to, 3.4, is an occupational question. So in a little bit, you'll see a presentation on our occupational pathway, and Whitney will describe the comparison of those values.
Thank you. Thank you.
Great. Thank you for that discussion. Dr. Fox.
Okay, hello. I'm not sure
We can hear you. We can hear you.
Okay, I'm not sure I can start my video. Okay, here we go. Yes, hi, Mary Fox. So my question kind of builds on that last discussion. And I noticed that Dr. Wegner very carefully in her slides noted where a peer review has already been done. So in some cases, right, there's been a HSRB review, or there's been a National Academy of Sciences, Engineering, and Medicine review. And our charge questions are about how the TSCA program is applying those values. And I believe Dr. Wagner said this in this way, focused on the context of TSCA. So I just want to make sure that I am understanding what you're asking the SACC to do.
Yeah, this is Susanna Wagner. Good question. So it's a little bit specific to each of the pathways, to the oral, to the inhalation, and the dermal. So in the case of the chronic inhalation, we are, I mean, I think the core answer to your question is really to look at the phrasing of the specific charge questions and how we acknowledge previous FACA reviews that have happened on each of the values, because the degree of review has been different across exposure routes, right? So for inhalation, chronic inhalation, those values developed by IRIS have already gone through peer review by NASM of the entire story. In the case of the dermal sensitization endpoint, the HSRB reviewed just the 2 human studies that are part of the broader weight of evidence that also includes animal and in vitro information. And so in that case, we want to acknowledge that we've already received some input from the HSRB, but that the HSRB has not reviewed the values themselves and the final conclusions that we came to in the weight of evidence narrative. For acute inhalation, we received HSRB review that was a bit more in depth than what we did for dermal. We got review of the 4 human studies that are the core quantitative basis for our acute value. And we also had HSRB review of an initial weight of evidence narrative. Now, there have been changes in response to that following that draft. So we now have a new value based on a new approach and rationale that we are seeking input on. But we're trying to, in each charge question, point to the previous and acknowledge that what we've heard in previous FACA reviews, so that the SACC has an appreciation for where the remaining gaps are and what previous feedback we are being responsive to. Does that help?
And if I can just add one thing, Anna, again, sorry, is that one of the reports from the Human Studies Review Board made a fairly insightful comment that the HSRB was asked to look at certain pieces, the NASM looked at certain pieces, but that they recommended that a federal advisory committee, in other words, the SACC, look at the totality of both the hazard and the exposure together to ensure that there's a logical and reasonable linkage between the hazard values and uncertainty factors, the calculation of the IRR, for example, and how that links to the exposure as part of risk characterization. And that is in part why we've asked these questions to you, all of you, as you are charged to look at the totality of the assessment and not individual pieces, because risk assessment is the whole is bigger than the parts. The sum is greater than the parts, wherever that is.
Does that answer your questions, Dr. Fox?
For now. Thank you.
Okay. Dr. Chason.
Hello, thank you. This is Chris Chason. Let's see. I just have a quick editorial question, sort of, or process. I'm making a plea to EPA to provide an alphabetical list of all acronyms used in these presentations and the report with the translation, not the definition, just the translation of those acronyms, because I pretty used to reading this stuff, but even I'm having a little trouble making sure that I'm following the conversation, and I'm sure that would be helpful to the public. And the second is just a question, George. When will the EPA PowerPoints be available along with recordings of the discussion? And thank you very much, EPA, for these presentations.
So Dr. Chasen, I don't have the answer to the exact timing. Tamu, do you know when these will be available?
Hi, yes, so the PowerPoint presentation was submitted to the SACC.
Oh, you sent those this weekend, didn't you?
Yes, as soon as we receive them, yes. And the transcript will be available 7 to 10 days after the meeting.
Not the transcript, but the recordings.
Oh,
Are they going to be on
yes.
YouTube or something?
The
So we can go back. There are a couple
yes, you can go
conversations I
back.
wanted to
Correct. You
revisit.
can go back to the links. I know that there may be some editing that may occur,
Yeah.
but that those links will be available, daily. But at some point, they will edit somewhat the links, and then they will be back online. But I will have that scheduled for you.
Okay, thank you. And I guess I just overlooked the PowerPoints. I apologize. Thank you.
Yeah. Thank you.
So I do have a couple of things. This is George Cobb that I meant to bring up during the last question, but I forgot. And first of all, it is that slide 21 and 27 that has your overall flow. Those are very helpful for digesting these kinds of documents. And I would say that perhaps every sub-document should have that particular figure in it somewhere early. And then the last thing is, I appreciate that the agency has done a good job trying to respond to the SACC's request for different format. My estimation is that the documents may be overly modular in that there may be too many, and somehow they could be somewhat coalesced into fewer numbers of documents, but still maintaining some separation between some of the major components. And I know that this is getting metered in, and you're trying to figure that out. So I'm not sure there's any question there. It's just more comment. I did get a comment in the chat from Dr. McClellan. Dr. McClellan, do you want to speak to the uncertainties in the risk evaluation here, or save that until we get to the technical discussion?
No, I'd like to raise this question now. Can you hear me?
Yes, we can.
Yes. We've had a continued conversation back and forth with regard to, I'll call it the supremacy of the charge questions and the extent to which comments on the IRIS document that had been reviewed by the National Academies. I want to emphasize that I think we, as a scientific committee, should address any scientific issues that relate to the risk evaluation, including those previously considered by the National Academies. And I want to emphasize, as a member of the National Academy, I've served on many committees, chaired many of them, and I certainly highly respect it. But I want to emphasize the Academy's review was largely conducted behind closed doors. It did not allow the participation of the public as is being done by this committee. I applaud the EPA for having this committee, even in a virtual session, being open to the public. I think that gives it a totally different tone. So I hope you will allow us to offer comments as they may arise from time to time, even if they had been addressed in the previous IRS review. Thank you.
Thanks for that comment. There wasn't necessarily a question there, was there?
Yes, the question really is, are we going to be allowed to discuss these very important issues that were raised within the IRS documentation, which is still ongoing revision, emphasizing that I think we, as a collective group of scientists, with public input, can offer comments that will be of great value to the agency and ultimately to the administrator.
So let's hear from the agency, and then I may speak to that as well. But let's hear from the EPA staff first.
Anna Lowett, again. So thanks for that comment. So our request is first and foremost with any panel, irrespective of formaldehyde or any other FACA or any other topic, is that—
I'm sorry, I couldn't hear who was speaking.
Anna Lowett, Senior Science Advisor.
Thank you.
Usually not quiet. I'll try it. We move the microphone. So our request, EPA's request of federal advisory committees, this one, any other topic, is to answer our charge questions. So we're asking you to answer our charge questions, but we're also not going to limit the conversation that you may have. So for example, a little while ago, one of the panelists is concerned, some of the panelists are concerned about some of the FIFRA uses in the pesticide program analysis. And as I mentioned earlier, that, if the panel chooses to put that in the report, we'll be referring those questions, but they may not go in the TSCA assessment. So, the extent to which this committee wants to talk about topics outside of our charge question, we appreciate that you have those comments, and we'll look at them and figure out what to do with them after the report comes out.
Great. And I think that's kind of what I would have said too. So thank you very much for that. Okay.
No further hands?
I see no further hands. So I think we can, let's see, how are we doing on time? I think we have time for the next presentation on the land and water pathways by Dr. Shiflett from EPA. Dr. Shiflett, are you there?
Hi there. Can you all hear me?
Yes.
We can now.
Great. So good afternoon. My name is Sean Shiflett. I am going to be presenting the assessment for formaldehyde exposures via the water and land pathway. Dr. Melody Bernot is here with me and will be available to answer any clarifying questions regarding ecological hazard, as well as broader questions about the environmental risk assessment. This section will also provide a high-level overview of some of the chemistry, fate, and transport considerations, as well as discuss the qualitative approach used for water and land pathways. We will also briefly touch on the air pathway, but that will be discussed more thoroughly later in the day. We have provided this document map and table to provide an orientation of how this section aligns with the other charge questions. Specifically, this section of the presentation applies to charge questions 2.1 and 2.2. The content that informs these questions are the chemistry, fate, and transport assessment, the environmental risk assessment, the environmental release assessment, the environmental risk assessment, and the human health risk assessment, as well as the environmental hazard assessment. Next slide, please. Here is an outline of the water and land pathway section. First, we will provide an overview of the chemistry, fate, and transport assessment. Next, we will cover the weight of scientific evidence for water and land pathways. And we will briefly review the environmental risk assessment. Next slide, please. Okay, let's start by talking about some of the chemistry, fate, and transport characteristics of formaldehyde. Formaldehyde is a highly volatile chemical that is soluble in water and very reactive. In this graphic, you can see many of the transformations that formaldehyde is known to go through in air and water. In water, formaldehyde quickly hydrates and can subsequently polymerize to form oligomers of various chain length. This transformation limits formaldehyde's persistence in aquatic environments. You can see an example of these transformations in the graphic shown in the bottom middle of the image. Note that these transformations may be in equilibrium with each other. These transformation products will similarly react with other compounds encountered in surface water, making downstream characterization challenging. The transformation products are expected to have similar toxicity profiles as formaldehyde. For these reasons, and due to the low bioaccumulation potential, aquatic organisms are not expected to be exposed to formaldehyde. Similarly, humans would not be exposed to formaldehyde in these environments. Formaldehyde is also not expected to absorb to soils or sediments based on its log KOC. Formaldehyde is expected to react with particle surfaces and transform into other chemicals. These soil conjugates would be structurally different and therefore have different physical and chemical properties as well as different toxicity profiles. Review of hazard data for ecological receptors indicate that the values identified for formaldehyde are generally protective of other transformation products. But like water, it is not expected that humans would be exposed to formaldehyde via these media. Formaldehyde may persist in outdoor air for multiple hours depending on the amount of direct sunlight. However, it may hydrate to form methylene glycol when it encounters clouds or moist air and can subsequently transform into formic acid. This assessment did not pursue the impact of formic acid on the environment, but does acknowledge that it is a potential outcome. Next slide, please. The weight of scientific evidence, or WOEs, for the water pathway and land pathways are presented on this slide. We can start again with the water pathway. As previously mentioned, environmental fate and transport data indicate formaldehyde will not persist in water. It hydrates within seconds and can subsequently transform into other oligomers of various chain length, as well as other potential chemical substances. Environmental releases of formaldehyde to water are small compared to many other releases of high priority substances. When reviewing monitoring databases for chemical concentrations of formaldehyde, very few entries were found and all had quality assurance or quality control concerns. Lastly, formaldehyde is not a bioaccumulative chemical. This means that neither formaldehyde or its reasonably foreseen transformation products are bioavailable and would not be absorbed into aquatic organisms. Thus, EPA concluded that further pursuit of the water pathway would not be relevant for the risk evaluation and limited the assessment to this qualitative approach. Similarly, environmental fate and transport data indicate that formaldehyde would not persist in soil or on land. Formaldehyde does not absorb to soil, sediment, or organic matter and will likely react with the particle surface. These reactions would create new chemical structures that cannot be characterized given the vast number of potential reactions. Other than release via underground injection, little evidence was found to suggest that there are substantial releases to land. Because the chemical substance has low releases and is unlikely to persist in these media, and because formaldehyde is not bioaccumulative, EPA concluded that further pursuit of the land pathway would not be relevant for the risk evaluation and limited the assessment to this qualitative approach. Next slide, please. So in conclusion, formaldehyde is not a concern for environmental organisms in land or water. Formaldehyde is not expected to persist in water, sediment, or soils based on its physical and chemical properties. In contrast, formaldehyde can persist in air for relevant periods of time, but hazard values for the ecological receptors identified are found above both modeled and monitored concentrations in ambient air. Regardless of the exposure scenario assumed for this environmental risk assessment, no risk was identified. This conclusion is supported further by monitoring data. The maximum measured concentration of formaldehyde in ambient outdoor air is 60.1 micrograms per cubic meter. This is well below the effects level and is expected to represent an aggregate exposure scenario. That is, exposure from multiple sources of formaldehyde. Taken together, we have high confidence in our conclusions that there is no risk to environmental organisms from exposure to formaldehyde. Last slide, please. And with that, I thank you for your attention and we'll take any clarifying questions.
Thank you, Dr. Shiflett. Are there questions from the committee to clarify presentation or charge? Well, the charge is coming up, but so if there are no questions, this is George Cobb. I have a couple of questions that are related. First of all, you showed a nice diagram that showed equilibria between formaldehyde and its transformation products in water. Was the equilibrium of formaldehyde between water and air considered at all? And given that there's no monitoring data to support any real outcome, was the equilibrium between air and water considered?
Thank you for the question. We ran a routine fugacity analysis that can be found in the appendix of the fate and transport analysis to consider whether or not formaldehyde might be released from water to air.
Okay, but then was that considered as part of the water, potential water concentrations of formaldehyde in water?
We did not use the fugacity analysis to estimate concentrations of formaldehyde in water.
Okay, so that's first question. The second question is the monitoring data that were alluded to but said that there were quality issues around those data. Are those reported anywhere in the documents that the committee has?
They are reported in the water quality portal results, which is a supplemental file.
Water, I need to write that down because that was the information I was looking for. Water quality portal.
Mm-hmm.
All right, I'll try to find this. That's very helpful. And one other aspect for me is, and this kind of cuts across charge questions, at least two charge questions. So there may be others that would like to take a stab at this either now or later. And that is, if we look at in looking at the hazard values, they were generated from toxicity tests that used formaldehyde or formalin as their active ingredient. And then the concentrations of formaldehyde were determined from that percent formaldehyde in those particular dosing solutions. And the concentrations that were observed to cause toxicity were not based on free formaldehyde in solution, but formaldehyde added to the solution. So I can't fathom how the agency can say that those toxicity values are being used on the exposure side, but then we're going to say that when formaldehyde is released into water, it will nearly totally dissociate or react so that we don't have to consider anything except the formaldehyde that's active, because I could not find in the toxicity test where the unhydrated formaldehyde was determined in those solutions. I don't think you can determine that actually. So I'm wondering how to address that, or how the agency did address that.
I can address at a very high level, but I'll invite Melody Bernot on to speak to the ecological hazard values. But this is a general challenge with formaldehyde as a chemical substance. When it is in water, it quickly dissolves and can form those other oligomers and other conjugates. Dr. Bernot, anything you want to add?
Yeah, no, I'm sorry. Thanks, Sean. I appreciate it. So I think it's a great question. I agree with Sean that it is a difficulty. And so in the environmental hazard, where we have all the toxicity values, in that environmental hazard module, we report active ingredients. So as you noted, so based on the percent formaldehyde. And so most toxicity tests are stabilized with methanol. And so that it's typically a 37% formaldehyde, though we do have some environmental hazard toxicity tests that use a purer form. And we talk about this, and certainly perhaps are welcome to committee comments as to whether there's more detail that's needed in the environmental hazard section, but it's difficult to, so analytically, if you were to run formaldehyde, it would be combined with methylene glycol and paraformaldehyde. There's a couple studies that we cite, particularly in the comparative toxicology section, where the paper does describe actual analytical measurements of multiple forms in the water, because that was the target of what they were doing. But for most studies, what they're actually measuring is likely a conglomerate of those three compounds.
Yeah, and so my question wasn't really about whether you could measure that effectively, because I understand the difficulties there. It was trying to square using that data for hazard determination for an outcome
Sure.
or toxicity assessment,
Sure.
and then saying that we're going to not consider formaldehyde in the environment basically in the same way.
So yeah, I get it now. Sorry, I don't mean to interrupt you.
That's fine.
But I can speak to that a little bit at least. Problem formulation in the environmental risk characterization focuses on the environmental release, the environmental monitoring data, the fate and chemistry of formaldehyde. And so the problem formulation that led to the qualitative evaluation has nothing to do with the hazard data, right? In terms of comparing it, it's a function of formaldehyde releases based on TSCA conditions of use and what would happen. So the tox data are typically stabilized formaldehyde, right? And so so back to my first point, that we're not comparing hazard values because it's a qualitative evaluation based upon the release, the monitoring, and the PChem and fate properties of formaldehyde. So we never do a comparison, particularly for water. We do a comparison for air, where we screen the environmental hazard concentrations with the monitored and modeled concentrations of formaldehyde in air.
I think this is starting to get into the discussion of the charge question, which
sure.
I'm going to admonish others not to do. So I don't want to blow the format myself. So we'll get back to that within the charge questions. Thank you for that answer. And Dr. Landis, you had a question.
Yeah, thanks. Unable to start video because your host has stopped it.
Just proceed then.
Okay, I got it. So I thought the reporting of the toxicity values was what I expected. My experience is that though it's mostly NOAA's LOX, occasional EC50, but I can't determine how that was figured out. And of course, with this kind of data, they're not really discussing dose response, especially LOX and NOAX. That's actually ANOVA with multiple comparisons. Did you go and get any of the initial data and do your own evaluation of it? I tend to be very wary of these calculations for two reasons. One, the concentrations are picked by the investigator. So it's not really the dose response curve. And you're nodding your head, so you get all this, but maybe not everyone does. And also a dose response curve will actually give you the entire inflection point, will give you an idea of perhaps where the slope goes to zero as a true threshold, not a NOAC, which is not a true threshold. Did you go back through and evaluate any of this data in that way, or did you not even, you probably didn't even have access to the initial data, did you?
So I think in some cases we did, in other cases we didn't, based upon that. Can you hear me?
Oh yeah,
Yeah,
great.
Melanie,
Sorry,
maybe I'd
we can
like
hear
to
you.
kind of like redirect the conversation a
Sure.
little bit, because
Yes.
we are getting a little off course. We are asking the SACC specific charge questions around the water and land pathways. And unfortunately, we did not ask any questions related to the ecological hazard values that were selected. So I do want to remind everyone of that.
So I'm asking a question to evaluate the reports that we got. And I would like to know that.
So I'll just very briefly summarize. So yes, we go into detail and evaluate the data very specifically where we have that data available. But again, we do not use the hazard data, particularly for water and for land as well. But because our pump formulation indicated that there would not be formaldehyde in water due to TSCA uses, so we don't even use those those hazard values in the environmental risk.
Okay, so if people find formalin and these derived materials in water column through routine monitoring, that negates your assumption, doesn't it?
Sure. I mean, we talk about the monitoring data, and we can certainly talk more about this with respect to the charge questions. I think going back to what Sean noted, we're trying to stay on task. I'm trying to answer your question at the same time, but do it briefly.
No, that's fine. But I'm trying to evaluate the risk assessment. I do this all the time.
Absolutely.
And this is a very interesting case. Yeah. George, I think I'll stop there. I have a lot more.
I think, Wayne, Dr. Landis, I think you and I have some of the similar kinds of questions that we're going to need to work through in the response to the charge. And just for full disclosure, we can't address the exposure side without understanding how it fits within the framework of the toxicity side. So I'm just stating that for the record, and there's some other aspects of this report where we may run into similar. We can't address the charge question as asked without addressing other topics that weren't specified in the charge.
Right, George, thanks for doing that. That I concur with that statement. I also am comparing this to the one done for FIFRA. We have that copy, and they're not identical. They're both very interesting and very useful. Thanks, George. Thanks everyone for your time.
Thank you for that discussion, everybody. Now I see Dr. Kim has a question as well.
Yes, my question is in regards to actually what we are defining as formaldehyde. If you look at the exposure, its inhalation is most significant. When you consider inhalation exposure, it is more like a gaseous form of formaldehyde, which is anhydride form of formaldehyde. But as you mentioned that in the water, it's majority of them are methylene chloride. So the added form of the formaldehyde is not necessarily gaseous form of formaldehyde. And to the best of my knowledge, there is analytical methodology that you can actually quantify the level of gaseous forms of formaldehyde in aqueous forms of the product. So I think it's important based on equilibrium. So I think it's important for us to define when you make risk assessment, what is formaldehyde actually are talking about? Would that it only include gaseous formaldehyde, or would it also include other form of formaldehyde that is considered to be equivalent. Maybe that they are toxicologically different, but that would impact significantly how we actually the outcome of risk assessment. So I think agencies probably need to, in my judgment, at least we have to really clearly define what is included in formaldehyde. That's my question. Thank you.
Dr. Shiflett, you or one of your colleagues have a response to that?
This is a tricky question because of the chemical nature of formaldehyde, and I don't think I can give you a very clean answer in this particular question. Formaldehyde is a speciating chemical. It can be multiple things, but under TSCA we are tasked to do a specific CAS number.
Okay. Fair enough. Well, we are now kind of in no man's land. We're 15 minutes ahead of schedule.
Oh, sorry, Chair.
I
raised
see.
my hand.
I see a hand. I am very sorry. I did not see that before.
Okay.
Please.
Sorry, this is Luo Ping Zhang. Just the echo with what Dr. Kim explained it. I understand it's a difficult question for EPA scientists to address, but I'm just trying to thinking because the nature of the formaldehyde in the I can't say that word, equilibrium. And can we think about this way? I'm just trying to make a comment and see what the EPA scientists would responded. So, for example, a lot of risk we evaluate for the formaldehyde risk, human health risk is with inhalation. So we can maybe agree if it's an inhalation exposure, that's pure the formaldehyde form, right? We are talking about different forms of the formaldehyde. But let's say if maybe even the dermal or some other types of consumers use for the, formaldehyde containing products. So that could be a mixture. So, I mean, I'm just thinking, maybe not it's difficult for the risk assessment, but for me as a, toxicologist or scientist, we can see different type of exposure. We would understand what's the major form of the formaldehyde exposed. This is just my little comment, and I want to see what the EPA scientists to respond to that difficult question. Yes, thank you.
Hi, Anna Lowett, Science Advisor. It is a difficult question, as you've heard from Sean a couple of times. I would invite the panel to give us feedback on some of these issues. If aspects of our assessment lack the clarity and the precision that the panel is looking for, we welcome those comments. And around the problem formulation of the land pathway, if we've missed some monitoring data or some use of some modeling information that might change our conclusion, we're looking forward to hear that feedback from the panel as we move into the other presentations later.
Thank you. So after I made the erroneous statement about being ahead of schedule, we're actually 45 minutes behind schedule. I'm in Central Time and I don't have my brain aligned to the schedule in my clock here. So at this point, I think it's time for us to take a break for lunch. I would like to inquire with the committee and with the agency, if we took a 45-minute lunch, would that be acceptable? Is anybody opposed to that? Is that okay?
I think we can do that. Yes. I think we can do 45 minutes and turn it around somewhat. Let's go.
That's okay with, if
Yep.
that's okay with everybody. I will share with the committee that I'm going to be having to take roll when we come back. So if you're not here, we'll know you're not here. Now, we'll cycle through the roll at least once, if not twice,
Yes.
to make sure we get as many people in here
Okay.
as possible.
Can you give me a time when that would be? I'm on West Coast time, so it's only 9:49 here.
So 10:30, 10:35-ish
That'd be good.
for you.
That'd be fine. Yeah, yeah, yep.
So there'll be a
Second
countdown on the screen, will there, for this, for the 45
Yes.
minutes?
Yes.
Yeah. So
Yep,
let's,
1:35 p.m.
yes,
Eastern.
let's do that.
Okay,
Thank you, everyone, and we'll see
Yep.
you after lunch.
great. Thank you.
Hi there, George.
Hey, William. Looks like we're all getting back.
Yeah. Yep, coming in.
It's not a long walk from the kitchen.
I was worried I wasn't going to get back. I went to a restaurant right across. Well, I have to go under the interstate. Somebody tried to back into me trying to skirt some traffic.
Oh, no. Oh, wow.
So, so are we in the public meeting now, or are we waiting to be let back in?
We're in.
We are definitely
Charlie,
in.
can you confirm we're still being recorded? Is that
We are.
correct? Yes.
We are.
Yes.
This is
Yeah.
public.
Yep.
Right. Thank you for confirming
So
that.
I'm trying to see. It looks like there's a fair number of people there here. Let me go ahead and start trying to do the roll. So since we're coming back from lunch, this is George Cobb speaking. Welcome back to our afternoon session of our first day. I think we had a really productive morning. And at this point, very quickly, I'd just like to go through a roll call. So Dr. Baker.
Here.
Thank you. Dr. Chasen. Dr. Ike.
Here.
Thank you. Dr. Fox.
Here.
Yeah, I see you. Dr. Graham.
Here.
Dr. Heiger Bernays.
Here.
There's one. Dr. Merced Nieves.
Here.
Thank you. Dr. Ottinger.
Here.
Here. All right. Dr. Prisbilla.
Present.
Dr. Rife.
Here.
Great. Dr. Rubin.
Here.
Dr. Rumpler. Dr. Voorhees.
I'm here.
Mr. Wright.
I'm here.
Dr. Barakal.
Present.
I found you this time on the list. Dr. Brycey.
Yep, I'm here.
Dr. Henneman, I think I see you there. Dr. Caden.
I'm here.
Dr. Kelly.
I'm here.
Dr. Kim, I see you.
Yes, here.
Dr. Lindis, Wayne, we just spoke. Dr. McClellan. Back to him. Dr. Strickland.
Here.
Great. Dr. Sweeney.
Present.
Dr. Wolf.
Present.
Dr. Young. Let's go back through real quick. Dr. Chason.
I'm present.
Great. Dr. Rumpler. Dr. McClellan. Dr. Young. Okay. So I guess we can go ahead and get started. We certainly have quorum. And Temu, is there anything we need to do before we start?
No, we can proceed with as planned on the agenda.
All right. Thank you.
Thank you.
So the next order of business is to look at the occupational exposures and risk assessments. And for that presentation, Dr. Hollingshead from the EPA will lead that discussion.
Sorry, just getting the audio all together. Okay. I am Whitney Hollenshed from the EPA. I will be covering the formaldehyde occupational exposure and risk assessment. This presentation will be focused on the content relevant to peer review charge question 3. Next slide. For charge question 3 on the occupational assessment, the relevant reference documents are the following: the draft human health hazard assessment, the draft human health risk assessment, and the draft occupational exposure assessment. We also have 2 supplemental files, which are on the diagram, but are available to the SACC, which is the draft RE occupational monitoring data summary and the draft RE occupational risk calculator. Next slide. So I will begin this presentation with a brief overview of the general approaches we use to estimate inhalation exposures from occupational conditions of use. Then I will be specifically discussing the integration of data from OSHA and our process for estimating acute exposures. Lastly, I will cover how we applied the hazard and exposure estimates for risk characterization. Next slide. So on this slide, I want to introduce the considerations included in an occupational exposure assessment. You have the setting. We consider things that occur in workplaces via workplace air and via direct contact with formaldehyde, which are the media. For population, we look at workers and occupational non-users. For routes, for workers, we look at dermal and inhalation, and then for occupational non-users, we look at inhalation. This assessment generally covers things occurring in workplaces, not necessarily things that may occur in homes, mobile homes, and vehicles, which will be covered in the indoor air assessment. Next slide. Is there a comment? I'll continue. So our approach to inhalation exposure estimates can be broken into 2 general categories: monitoring data and modeling approaches. For monitoring data for formaldehyde, we had over 800 sources tagged for monitoring data across peer review and gray literature. So we prioritized the use of personal breathing zone monitoring data, which were sampled after 1992 to build a robust data set. We chose the year 1992 because that was the latest year that the OSHA regulatory permissible exposure limit was enacted. This reduced uncertainties with relying on data that may not reflect the current regulatory environment for the TSCA conditions of use. The supplemental file, formaldehyde draft RE occupational monitoring data summary, contains select studies that we considered in our analysis. In this file, you will see that we categorize the monitoring data by the type of sampling, area versus personal breathing zone data, as well as a variety of sampling durations identified, whether 15-minute or 12-hour time-weighted averages. Where we had discrete data for an occupational exposure scenario, we integrated that monitoring data across the various sources to provide a 50th and 95th percentile, which we categorize as central tendency and high end of the monitored data set. A full list of studies, so like I said, the data summary contains selected studies. The full list of studies would be included in the formaldehyde draft RE data quality evaluation and data extraction information for environmental release and occupational exposure. For reference with the formaldehyde assessment, most of our scenarios fall under monitoring data. For a few scenarios where monitoring data was not available or limited, we did employ modeling approaches, either probabilistic approaches or deterministic approaches. Probabilistic approaches are ones that you've seen previously that have been peer-reviewed recently in the 1,4-dioxane SACC meeting. Next slide. So now we'll go specific to charge question 3.1 and 3.2. So one of the key sources that we use is the OSHA chemical exposure health data. OSHA CEHD is a publicly available database of industrial hygiene sampling done during OSHA facility inspections. OSHA performs targeted inspections of certain industries based on national and regional emphasis programs to address worker complaints or other referrals, and often for measuring these concentrations to their regulatory limits. This database includes personal breathing zone data, area monitoring data, bulk samples, wipe samples, and serum samples. It does provide us with the place of inspection for that particular company that provides us the industry classification codes they may be using, sample date, sample result, and the corresponding sample time and air value. It does not include information such as the worker activities or the sampling plans. Next slide. So I'll be kind of going over a step-by-step of our specific approach for this particular database. I will have you bear with me as there is animation on the slides. It's going to take us a second. Can you click? There we go. Our exact approach in integrating OSHA CEHD starts with downloading all the formaldehyde data sampled after 1992 from the OSHA CEHD database. Then we sort and filter the data to remove sites where all measurements were recorded as 0 or below the limit of detection. This particular data has a higher level of uncertainty on the formaldehyde was at the site at the time of inspection. Then we also do not consider the serum, bulk, wipe, and blank samples because we're using the OSHA database for inhalation monitoring estimates. You can click, yep. You can continue to click, I think 4 more times. So we just have all of the trees, thank you. The relevant, then we take the data and then we need to assign that to the occupational exposure scenario. We do this using a NICS to OES crosswalk. NICS is the North American Industry Classification System. This provides information on the primary industry for the site. For older data, sometimes they use an older code, which is a standard industrial classification code, which we do have a standard crosswalk between these SACC codes to NICS codes that we use. If you are looking for more information, you can find this NICS OES crosswalk in Appendix D of the draft Occupational Exposure Assessment. So once we have identified the data relevant for the in-scope conditions of use, we then sort the data samples by the sampling done on the same worker. Once we have the sampling done on the same worker, we calculate 8-hour time weighted average, as well as extract relevant 15-minute data. Lastly, we address samples that are below the detection limit. Generally, we do this based on the exposure scenario, and depending on the geometric standard deviation of the exposure scenario, we will either divide the LOD by 2 or by the square root of 2. Next slide. So continuing on with charge question 3.1, with the OSHA database, we saw specifically for formaldehyde, the OSHA compliance officers collected multiple samples from the same worker. So for example, we may have one sample that was measured for 200 minutes. We may have on the same worker a sample that was measured for 15 minutes, and then another sample measured for 115 minutes. EPA takes all of this data and constructs that 8-hour TWA. Next slide. So this is a breakdown of the combined sample time per worker. So as you can see, we identified thousands of unique workers that were sampled from the OSHA database. And this is after removing data that was sampled prior to 1992, as well as this is data specific to occupational exposure scenarios in scope. So you can see from this that we have a large number of workers that were sampled for less than an hour. We suspect that this may be because formaldehyde has both a 8-hour PEL and a 15-minute short-term exposure limit still. So click once. So we decided in using the OSHA data for full shifts, so when looking at a chronic exposure, that we would only use data that was measured for most of the full shift. So for OSHA, they define their full shift to be 8 hours minus an hour, so 7 hours. However, we applied additional leniency to workers moving in and out of regulatory areas. Maybe they're changing in and out of PPE, taking lunch, so somewhere outside of the work area. So we decided to could do a threshold of 5.5 hours or 330 minutes for the extraction of samples for a full shift analysis. Next slide. So for chronic exposures, EPA's objective was to calculate the time-weighted average over a worker's full shift. This is typically an 8-hour shift or longer, where the air concentration of formaldehyde exposed to the worker may vary through different tasks. Click once. Where the total sample time is less than 8 hours, an assumption needs to be made about the exposure potential for the remainder of the shift. For some studies, EPA has assumed, based on the sampling objectives, that sample time is intended to represent a full shift of exposure. For integration of OSHA data, we decided to calculate an 8-hour time-weighted average, assuming unsampled time is 0. This may potentially underestimate exposures if during the actual unsampled time exposures are non-zero, but it does provide a kind of lower bound for that sample. Next slide. So we also did a analysis at the end of the slide. I can provide you with the appendix name. It's blinking from my mind at the correct moment, but we do have an appendix section where we looked at, what the impacts of these assumptions were. So this is just one table of one occupational exposure scenario, processing of formaldehyde into formulations, mixtures, and reaction products. This is solely a review of the data from OSHA. The actual data for the exposure scenarios integrates data beyond just OSHA data. But this was just to look at the impact it was on our OSHA data. So for this particular scenario, we identified 157 worker samples, 98 of which fell below our threshold of 330 minutes of time sampled. Then we calculated our central tendency high in the OSHA database using our approaches, which arrives at a central tendency of 0.07 ppm and a high end of 0.77 ppm. Okay. If the data was not adjusted to assume that unsampled time was 0, this would result in a slight increase to a central tendency of 0.07 and a high end of 0.88 ppm. If all of the combined samples were included, then there's a sizable increase in these concentrations. These values incorporate a number of samples covering less than a typical work shift. Then if we were to take all the samples, but setting the time unsampled to 0, results in a time-weighted average lower than our current approach. Therefore, we kind of believe that the 5.5-hour thresholds help reduces the level of uncertainty in the exposure estimates by only using measurement data that we felt confidently covered most of the typical worker shifts. The impact of an 8-hour adjustment is also minimized when only using monitoring data greater than 5.5 hours, with only a difference of 10% across an average of 10% across the different occupational exposure scenarios. Oh, sorry. Okay, sorry. Next slide. So now I'll be covering our approach for acute exposures. For estimating peak exposures, EPA extracted monitoring data measured for 15 minutes. We did this because we assumed that OSHA inspectors or other industrial hygienists that measured for 15 minutes were measuring it for comparison to the short-term exposure limit, and therefore activities expected to be peak exposures for the worker. We calculated a 50th and 95th percentile of these 15-minute sample data that we then used for the acute risk. In many scenarios, the percentage of the below detection limits were above 50% of the database, given the sample volumes for these 15-minute measurements. Next slide. So now we'll be covering charge question 3.2. So as explained earlier during the health hazard section of the presentation, we assess acute risk to eye irritation based on multiple studies in adult volunteers exposed in controlled settings. The duration of exposure to formaldehyde in the studies varied between 3 to 5 hours, including 2 studies that included 15-minute intervals of increased formaldehyde concentration during the 3 to 5 hours of exposure. The acute inhalation hazard value derived based on these studies is intended to define a threshold concentration below which no sensory irritation is expected. This hazard value is independent of duration. For the occupational exposure aspect of it, we're applying this to a population of occupational workers older than 16. We use the 50th and 95th percentile of the monitored data set, assumed to be measured during our work activities that are expected to be high exposure, so peak exposures. The duration that we applied this to was 15 minutes, and we did not assume any frequency with those acute risk calculations. Next slide. So as discussed earlier, for the non-cancer risks from repeated exposures, EPA relied on the draft IRIS reference concentration as the basis for the chronic non-cancer hazard value in this assessment. While OCSPP disaggregated the IRIS reference concentration into a POD and a corresponding uncertainty factors to match our MOE approach, POD is quantitatively equivalent to using the draft IRIS reference concentration value of 0.007 milligrams per meter cubed. So this means that on the hazard side, EPA's hazard values are based on respiratory effects reported in epidemiology studies. These studies were primarily focused on effects in children following chronic exposure to formaldehyde in indoor environments. Characterization of exposure durations in these hazard studies are somewhat variable across studies, but they are understood to represent chronic exposure. On the exposure side, we're again looking at occupational workers, including occupational non-users, ages 16 and older. We're looking at the 50th and 95th percentile of those occupational data set, whether monitored or modeled. We take an 8-hour time TWA, and we average that over 24 hours for comparison with the hazard values. For the frequency, we calculated 2 different risks, a subchronic and a chronic, that you'll see in the occupational risk calculator. For the subchronic, we assume for most scenarios 22 days over a month and 250 days over a year for chronic. Next slide. Okay. For chronic cancer hazard in the inhalation IUR, we again relied on the analysis completed in the IRIS assessment. The key studies used as a basis for the IUR is based on an occupational cohort study that correlated full shift, 8-hour time-weighted averages, concentrations of formaldehyde in industrial settings for risk for cancer. IRIS derived an IUR from this study in terms of continuous exposure, but our risk estimates incorporated workplace exposure durations adjustments. The risk characterization used the lifetime average daily concentrations, which is the average daily concentration used for non-cancer, so the 250 days over a year, with an expected worker tenure of 31 to 40 years. So we've used 31 years for social tendency, and high end, we use 40 years over a 78-year lifetime. Next slide. So this discusses the draft occupational exposure values. So using the hazard and exposure values, as I just discussed, we calculated the draft occupational exposure value. EPA calculates this draft occupational exposure value to summarize the occupational exposure scenarios and the sensitive health endpoints into single values. Note, TSCA requires risk evaluations to be conducted without consideration of costs and other non-risk factors. And thus this draft occupational exposure value represents a risk-only number. This calculated draft value for formaldehyde represents the exposure concentrations below which workers and ONUs are not expected to exhibit any appreciable risk of adverse toxicological outcomes, accounting for potentially exposed and susceptible populations. Please note that there is a correction here from the HHRA on the chronic cancer. I think it was 1.33, but it's meant to be 0.133 milligram per meter cubed. All right, next slide. So thank you for your attention, and I will now take clarifying questions.
All right, thank you for that presentation. I see a hand from Dr. Caden.
Thank you. Sorry about my delay. I'm not Zoom savvy. I just, one of the last things you said talked about adverse health outcomes. So even for the acute health outcome, you're looking only at adverse health outcomes. Is that correct? And I have a follow-up if your answer is what I think it is.
So for the draft occupational exposure values, we're using the same health values that we use for the risk estimates.
Okay.
Does that answer your question?
Well, it does, because it's sensory irritation, which is not an adverse health outcome. It's an annoyance as opposed to an adverse health outcome. So I wonder if you'd be better off, particularly for the occupational cohort, looking at some other number. Either that or justify why sensory irritation, which is reversible, is an adverse health outcome.
So Dr. Caden Hyatt, Santa Loa, Senior Science Advisor. Yeah, I think those are good points, and we'd be looking for your input in the questions related to, I don't remember the numbers off my head, but we are asking both questions about the acute in question 1, and we have the relationship, the intersection of the acute with the hazard and the exposure in question 2 or 3, I can't remember. So, we're looking for your comments there.
Okay, thank you.
Yes, thank you. Dr. Yang.
By the way, it's John. Okay, so thank you for the presentation, and it's very, very helpful and useful. But I just want to qualify couple things I want to just confirm. Is OSHA database, the OSHA, what do you call the database you apply? Is the OSHA database include or exclude the data from embalming or like a pathologist? We call technical or technicians. Is the OSHA database was excluded that?
So if I think I'm understanding your question correctly, so OSHA covers different occupational settings. So they would cover, are you asking if they're excluding certain types of jobs, or are you talking about ambient air?
Yeah, because from last presentation we heard is embalming or medical technicians are not included in this risk assessment. So my question is, when you apply the OSHA, what is it called, the database, is that included or not? So this is my question number 1 for you.
Yeah. Okay.
And the 2, after I heard your presentation, the more I think occupational exposure should include.
So, okay.
Okay, and I just want to put this in the records. I really feel put that part into FIFRA, into pesticides. I'm not so sure that's, I still don't quite understand why EPA does that, to put that very important exposure, occupational exposure, took this piece out from here, put it in the pesticides. So I'm not so sure that's, at least I don't quite understand why EPA is doing that.
So thank you for the question. Before the agency asks, I think we've had this question a couple of times already, and I think the APA staff have answered, but I'm going to give them a chance to answer. And but I think we've heard this question a couple of times and they've given an answer, but let's see what they have to say this time.
So I want to clarify. So this is Whitney Hollinsher from the EPA speaking. So the OSHA database is not restricted to TSCA uses only. So I wanted to clarify that. So when we take the OSHA database, when we're trying to identify data relevant to our occupational exposure scenarios, that's when we kind of do the analysis of whether we think it's a TSCA condition of use or not. I think that hopefully addresses your question. So who's covered under OSHA? So the OSHA database is based on the OSHA inspections, and what's covered under that is it's separate from the TSCA conditions of use. So it could cover facilities that may be using formaldehyde for an FDA or for use. But that's part of the mapping process that we do in determining whether we want to use that data for the exposure standards that are in scope.
And to add to that, Anna, on the pesticide uses, so keep in mind that pesticide and their use and their exposures are covered under FIFRA, the Federal Insecticide, Rodenticide, Fungicide Act. I should know that by heart. Things covered under FIFRA are within the risk assessment developed by our colleagues at the Office of Pesticide Programs. So they have done their exposure assessment in their assessment. So EPA is covering that. It's just in a different place.
So, yeah, thank you for that. Dr. Graham.
Hello, thank you. This is Cynthia Graham. I would like to ask for the definition of central tendency that you mentioned early in your presentation and how that number is derived.
So this is Winnie Hollenshed from the EPA. Sorry, my voice is leaving me. So for central tendency, we usually use the 50th percentile. It depends on the number of samples that we have. Sometimes we may use the midpoint if we only have a limited number of samples. But for most scenarios, for formaldehyde, we had a lot of samples. So most scenarios are 50% of the data.
Thank you.
So next question is from Dr. Brycey.
Yes, thank you, Pat Brycey. So a few slides back, in two different slides, you had a line that referred to, and I'm sure I'm not going to get it exactly right, but 8 hours averaged over 24 hours. Do you recall what I'm referring to?
This is Winnie Hollenshed from EPA. Yes, this is the chronic risk calculation.
What does that mean?
Mm.
8 hours average. So you calculated 24-hour time weighted average based on an 8-hour time weighted average. What is? I'm
So
not sure.
This is in the risk equation. So when we do the risk calculation, we have an averaging time that we apply. So I can give me maybe I'll follow up with the actual appendix section where we actually have the equations for the risk. But essentially, we're taking that 8-hour TWA, and then we're applying an averaging time to compare it to the hazard. So the hazard is continuous, so 24 hours.
So is that relevant to the assessment we're doing now, or is that a separate concern?
So this is Winnie Hollenshed from the EPA. Are you asking if that is something relevant to your charge questions?
Yes.
I'm understanding correctly. Okay. I would consider that to be yes.
So, yeah, that's good discussion. So, Dr. Brycey, if that answers your question, that raised a question with me, if it's okay.
Yeah, exactly.
So, this is George Kopp. So, I didn't really thoroughly review that part of the document because it's not my expertise, but are you saying that you took an 8-hour time weighted average and multiplied it by 3 to get to a 24-hour? Or are you saying that you took the 8-hour time weighted average and assumed that was the sole exposure that occurred during the 24-hour period, or something different?
Sorry, I had to get back to the buttons. This is Whitney Hollenshed from the EPA. So we calculate what's considered an average daily concentration. So that's the term that we use that's in the risk calculations. So essentially that assumes, yes, that they're not exposed for the remaining 24 hours. So it's more like the, I was trying to bring up the equation, but yes, it's more like assuming that they're not exposed. So the risk from it are only based on the exposures from occupational.
But the calculation is the same calculation you showed earlier for a TWA calculation. Well, it's for 24 hours instead of 8, and instead of assuming, the 2 hours are 0, you're assuming the rest of the day is 0.
Yeah. So
my understanding correct?
Make sure I wasn't still on mute. So this is still Whitney Holmshed from the EPA. So if you go to Appendix F, those are the exposure concentrations that we calculate. So those are what's going to be used in the risk equation. So for the chronic one, you have I don't know if I can't really share my screen, but if you go to page 147 in the human health risk assessment, the draft risk assessment. So you're looking at your 8-hour time weighted average times your exposure duration, the exposure frequency. For this one, it's working years, but the working years will cancel out. And that's all over the averaging time. So essentially what we're assuming is that for the remaining of the 24 hours, they're not exposed. So we're normalizing to a 24-hour average in a way. Hopefully that clarifies it.
Yeah, but then I guess you purposely decided to exclude the possibility that they would be exposed in their car, in their home, all the other non-occupational routes might be there as well.
So Dr. Rossi, that's a great point. I think that's to address the charge question, your comments and I have the same comment. I'll just briefly say, in the environmental exposures, they looked at formaldehyde in the air, and the EPA saw 60.1 micrograms per cubic meter, which is higher than the point of departure. So that doesn't make sense that you wouldn't have non-occupational exposure after the fact. So we can have all of those discussions during the charge question if that's okay.
Got it. All right. Sorry.
And Dr. Hollinshed, thank you for answering those questions. That's very helpful. We do have a few more. Dr. Wolf.
Yeah, thank you. So just clarification on slide 52, you talk about you removed the sites where data were all 0. And I just wondered, I understand trying to get at the worst case scenario, but did removing the zeros have any impact on some of your calculations on the mean or the average calculations? Because it seems like one would want to know, populations of people that aren't exposed.
So this is Whitney Hollinshed. I want to clarify for the prior question that would be covered under the aggregate charge question. And then I will address this question. So for the ones that are all 0, so by that I mean we have that OSHA data, all of the measurements were 0. We have no indication that formaldehyde was present in the facility. Okay. So we did not actually calculate what that 50th and 95th percentile would be with those included, but for sure that would decrease it. Basically, we've seen in some of the NIOSH human health evaluations that sometimes they are measuring for formaldehyde because they have symptoms that they think may have been caused by formaldehyde. So in this particular case, we didn't want to incorporate anything that we weren't certain formaldehyde was actually present. And because we don't have the sampling plans, we don't know exactly why they were measuring for formaldehyde.
Okay, so it was more of a technical decision that shouldn't impact the calculations then. Thank you.
Okay, Mr. Wright.
Yeah. I've got 2 very short and simple ones. The first is in your description of the data sources Wait a minute, I was just asked to start my video. There we go. In your description of the data sources, you listed several sources other than OSHA, or along with OSHA, but it appeared that the only analysis that was done was of the OSHA data. Is that correct? Do I have that right?
No. So this is Whitney Hollenshed from the EPA. No, so in the individual occupational exposure scenarios, we integrate across OSHA data, data submitted by industry, data we may have seen in peer-reviewed literature. So all of that's incorporated into that 50th and 95th percentile. When I was referencing earlier was in appendix section where we just did a comparison of the assumptions, such as the assumption of excluding data that was measured for less than 330 minutes. So we just did a comparison between what the values would be specific to the OSHA database. But in the actual estimates for an exposure scenario, they incorporate all of the monitoring data that we felt sufficiently characterized that exposure scenario, that was measured after 1992, and that was discrete, that we had that individual samples to integrate. So for some samples, for some exposure scenarios, most of the data is actually from industry.
Okay, thank you. The second question is in deriving some sort of average for industrial hygiene data, it's common to use the geometric mean, and you use the median essentially as the 50th percentile. I wonder if you had done any kind of analysis using the geometric mean, and if so, what the results were and how they compare to the analysis using the median.
So this is Whitney Hollenshed from EPA. We have not done that analysis, but we welcome any feedback that you have.
Okay, thank you.
Okay, I see Dr. Graham's hand is still up. Is that for another question or it's simply still raised? Ah, it disappeared. I think that answers my question. Okay, so if there are no other questions, thank you, Dr. Hollenshed, for that presentation. And now we can move to, you know what, I have one question. I'm very sorry, I forgot. Is there any way to go back to slide 57? Ooh, maybe I had the slide wrong. Can you keep going backwards? Sorry. Where was the where was the equation? There was the equation that had the calculation to get to the, I thought it was 57 to
Yes.
the
So I think that's 57. I think it's just the animation. Are you talking about the 8 hour?
Yeah, it's the next thing over, I think, once you click it again.
Yeah.
This
one.
Yeah.
So that last term in that numerator has a 0 times something. So that means that term is just 0, or is that a typo?
No, that is correct. So this is Whitney Hollenshed speaking from EPA, but that is correct, yes. So we assumed, so that's the second bullet part, we're assuming unsampled time. So in the graph you have where they maybe only measured for 6 hours. And so we have, assuming that they worked an 8-hour shift, that's 2 hours that we don't know the formaldehyde exposure. So the way that we treated the ocean data is that we calculated 8-hour CWA, assuming that an unsampled time is 0.
Okay. I simply wanted to make sure I had that right in my mind. And I understand what you're saying now.
Mm-hmm.
And I appreciate you clarifying that for me. It was going by pretty quick, and thank you again for clarifying. And now that Dr. Landis has his hand up now.
Keep hitting the camera, but
I'm locked out from the camera for some reason. Maybe I've been bad today.
Yeah,
So
just
I have a
go ahead and
question
speak.
for the human health, especially with the equations and so forth. I very typically use Monte Carlo and probability distributions, especially instead of using a mean or median or some of the derived value. It's pretty normal for us to do a probabilistic analysis. And because of this, I've gotten to be very wary of where the tails of distributions are. And often in environmental sampling, you don't have Gaussian distributions. You have highly skewed distributions. My question is, do you sometimes have highly skewed distributions? And two, is it not typical to use probabilistic tools to actually look at distributions and not a central tendency or central value?
Okay, this is Whitney Hollenshed from the EPA. So they're not perfect distributions, the data that we receive.
That's fine.
Yeah, so that's to answer that question. We haven't looked at other probabilistic other than looking at the 50th and the 95th percentile for characterizing the exposure. So we would be welcome to any suggestions that you may have.
Absolutely.
I think one thing to highlight in a clarifying for the occupational exposure assessment is that we're looking at data across different sites, different job categories in some cases. So we do see a variability, and that variability may be due to different sites and their engineering controls, and they may have one site versus the other side.
Right.
So just something to consider in your response.
So I guess I'm asking, is that a cultural norm to not use probabilistic means? Because you don't need an equation for a distribution. There's other ways that you can do this just by sampling and so forth to actually get these questions. Or is there prior experience that these kinds of tools would not reduce the uncertainty or add knowledge to the analysis?
So this is Whitney from the EPA. Can you clarify? So we're using the monitoring data that's available to us. Do you mean running it through some different types of model, or you mean actually sampling? Because
no,
we don't
sampling data. If you have sampling information and the actual measurements, from that you can get distributions to which you could then sample to see what the ultimate distribution would be from that equation. I mean, this is my seniors and first year grad students do this kind of thing. It's what we do. And because in ecological systems, we never have a Gaussian distribution is not very common. And so we're used to doing this. But I haven't seen it so much in the stuff I've been reviewing. I guess I'm trying to get at, is it not typically done? Is there some other cultural reason why it's not done, a regulatory reason? Or it's just not, I guess I'm trying to understand why these tools aren't tried or used. And I'm just asking. I find them very useful. I know many other people do too. Okay.
So we will welcome, this is Whitney Hollenshed from the EPA. To get used to this. We'll welcome any comments that you have, any suggestions, any other approaches to using the data.
Okay.
And we'll look at it at that point.
All right.
So, yeah, this is George Call. I think that's the thing is maybe if we suggest that be done, that's something to do during the response to the charge.
Well, I just didn't want to ask to be done, but they already do it. They just didn't have it this time.
Understood.
Okay.
Understood.
Thank you.
Yeah. Dr. Chason.
Thank you, Dr. Cobb and Dr. Landis. Perhaps you could guide us this issue that Dr. Landis brought up. I have found in many of the sections similar comments initially my thoughts were focused specifically to whatever issue was being discussed at those paragraphs, but I find that to be relatively generic, and perhaps Dr. Cobb, you could guide us into a general presentation or response to EPA on the use of probabilistic techniques, not just models, but examination of data, et cetera, those kinds of things. And I would, because I'm also going to relate some of these points in 5.4 and 4.1 and places like that, where we're talking also about monitoring information. So maybe it'd be more helpful for the agency. Please think about that. And if you can instruct or collect ideas from across the SAP for more useful general commentary back to EPA on this, if you think that would be helpful, that's one way to do it rather than fragment these comments throughout the presentation. Thank you.
Surely, we could have some overarching comments towards the end of the report.
Thank you.
All right. I don't see any additional questions. So I think now we do have the opportunity to move forward in our agenda. So thank you again, Dr. Hollingshed. And now we can move to the consumer exposure assessment. And this is going to be Dr. Morales. Did I get that right? Nice.
This is Giovanni Morales.
Hi. So we'll be happy to hear your presentation.
Okay. Hi, everyone. Again, my name is Giovanni Morales. I will be providing a presentation on the consumer exposure assessment. Next slide, please. This presentation is structured according to Charge 4, whose relevant documents are listed on your screen. Next slide, please. I will begin with a brief overview of the consumer exposure assessment. Then I will be specifically discussing what is in and out of scope, our approach for assessing inhalation and dermal exposures from consumer products, articles. Lastly, I will cover how we applied the hazard and exposure estimates for risk characterization. Next slide, please. According to 40 CFR 711.3, a consumer use is the use of a chemical substance, including as part of a product or article when sold and made available for their use, based on assumed activity and usage patterns documented in the literature. The formaldehyde consumer exposure assessment is specifically focused on the intermittent use of products and articles that are formulated with some form of formaldehyde, resulting in shorter term events like using a glue product for 50 minutes per day for a craft project, or the repetitive use of a product or article over an extended period of time. Next slide, please. So what is in scope for this assessment? Formaldehyde consumer exposures were quantified for floor coverings, insulation, clothing, plastics, liquid photographic processing solutions, and so on. Next slide. What is beyond the scope of this assessment? Formaldehyde exposures were not quantified for the sources listed on your screen, including consumer products like plastics used for food storage and distribution, pesticides and disinfectants, including preservatives used in taxidermy, sources such as smoking and combustion. Next slide. The formaldehyde consumer exposure assessment was composed of the key components listed on your screen. That is, articles and products used through which formaldehyde is emitted to the air, or if in liquid form, is directly touched, leading to consumer exposure, which is generally expected to occur via inhalation or dermally, respectively. Bystanders are assumed to only acquire inhalation exposure since they are not actively using the product or article. Next slide. Should be emphasized that the consumer exposures occur through an active use of a product or article in a room of use. While that product or article is actively being used, there may be people located in the room of use, away from where the product is being used or somewhere else in the residence. These individuals are referred as bystanders and typically acquire less inhalation exposure compared to consumers. They are not expected to be dermally exposed while the product or article is being actively used, since they are not using the product or article themselves. Example products and articles are listed on your screen. Next slide. Tables B4 and B7 in the Consumer Exposure Model, or CEM, user guide appendices identify sources of key default parameters associated with specific products and articles. In general, CEM's three most sensitive parameters, including amounts used, duration, and frequency of use, preset inputs come from product and article literature, the most common of which are listed at the bottom of the slide. Duration and frequency of use come from the 1987 Westat survey and the Exposure Factors Handbook. The weight fractions of formaldehyde in products and articles were primarily identified via an online search of relevant safety data sheets. In cases where it was difficult to trace a product or article weight fraction, EPA used the Chemical Data Reporting, or CDR, and Formaldehyde Use Report. These products or articles were assumed to be on the market at the time of this search in May of 2023. Next slide, please. To assess consumer inhalation exposures, we identified relevant TSCA conditions of use, or COUs, in consultation with our risk management team. This led to the identification of the relevant products and articles using the previously noted sources. Then we matched the identified formaldehyde-based products and articles with CEM preset product and article amount, duration, and frequency of use. Finally, using CEM outputs, EPA calculated 15-minute peak concentrations based on high-end values and chronic average daily concentrations using preset central tendency, amount, duration, and frequency, and weight fractions when appropriate. Next slide, please. This schematic provides a general overview of the formaldehyde consumer inhalation exposure assessment, whereby formaldehyde concentrations were estimated using CEM by considering whether the individuals exposed predominantly stay at home or are home part of the time. We also consider the product or article specific duration, frequency, and amount used, whether the individuals exposed are expected to be only consumers or both consumers and bystanders. Again, consumers are expected to be in the area or room of use, highlighted in blue, whereas the bystanders is assumed to be away from that area or outside of the room of use. In this case, that is the rest of the home. We also consider the physical chemical properties such as molecular weight, partition coefficient, among other relevant chemical properties. And product properties, including weight fractions, are also considered. Finally, we consider residential environment attributes, including room size and ventilation rate. Next slide, please. As an example, here we present the 15-minute peak exposure concentrations for the use of glues based on high-end inputs. Moving in a clockwise fashion, starting from the bottom left of the slide, duration of use is 60 minutes. Frequency of use is 1 day, as the 15-minute peak exposure is expected to occur within that 24 hours. The amount used is expected to be 30 grams per event. consumers or bystanders are expected to be exposed. The molecular weight of formaldehyde is about 30 grams per mole. The weight fraction for this product is 10%. And the room of use is a utility room. By default, the room of use is going to dictate what the interzonal ventilation rate is going to be. Once we combine all of the requisite inputs, we arrive at the exposure concentrations noted at the bottom right of the slide, whereby we have an estimated 15-minute peak concentration for consumers and bystanders based on high-end inputs. Next slide, please. Similarly, we can calculate lifetime chronic average daily concentration exposures for glues, where again, we would change key parameters, including duration, frequency, and amount used, this time using central tendency parameters. In this case, the duration of use is 20 minutes. Frequency of use is 52 days instead of 1 day. And the amount used is going to be a third of the amount from the previous acute scenario, or 10 grams. From this scenario, we assume exposures will occur primarily to a consumer over a lifetime. The molecular weight of formaldehyde is about 30 grams per mole. Weight fraction is going to be 0.75% instead of 10%. Room of use will remain the same as the utility room. In all, we get a consumer chronic average daily concentration of 36.6 micrograms per cubic meter based on a 57-year lifetime period of exposure. Next slide, please. As previously presented by Susanna Wegner, the dermal point of departure was generated according to amount per skin surface area, or micrograms per centimeter squared of skin. The thin film model was used to assess dermal exposures to liquid products using an Excel spreadsheet through which we estimated dermal loading concentrations in micrograms per centimeter square of skin to match the BOD units. Using an application rate, which is the weight fraction, multiplied by the QU constant, or the amount of the chemical that remains on the skin during or after use. A QU of 10.3 milligrams per centimeter square was used to approximate hand immersion and wiping experiments using oil-based products or viscous liquid-based products, as reported by Chinali et al. 1992. Next slide, please. Here is an example of a dermal loading calculation for crafting paint. In this case, our weight fraction is 10%, and the QU constant is 10.3 milligrams per centimeter squared. After multiplying these two parameters and applying a few conversion factors, we get a dermal loading concentration of 10.3 micrograms per centimeter squared. Estimated dermal loading was driven by the application rate, which varied across products. The higher the application rate, the higher the calculated dermal loading. Next slide, please. Regarding the application of the identified chronic inhalation non-cancer point of departure for the assessment of consumer inhalation exposure, on the hazard side, EPA derived hazard values based on respiratory effects reported in epidemiology studies. These studies were primarily focused on effects in children following chronic exposure to formaldehyde in indoor air environments. Characterization of exposure durations in these hazard studies are somewhat variable across studies, but they are understood to represent chronic exposure. On the exposure side, exposures were assumed to occur to consumers and bystanders during product or article use for relevant age groups. The calculation of chronic exposure concentration was based upon the use of central tendency modeling inputs, including durations ranging from 10 minutes to 4 hours, and for 12 or 57 years, depending on the COU. Next slide, please. Regarding the application of the Identified Cancer Inhalation Unit Risk, or IUR, for the assessment of consumer inhalation exposure, on the hazard side, the basis for the IUR are nasopharyngeal cancers in an occupational cohort. IRIS derived an IUR from this study in terms of continuous exposures, but our risk estimates incorporate duration and frequency adjustments to reflect the nature of specific consumer COUs. For the consumer exposure assessment, exposures were assumed to occur to consumers and bystanders during product or article use for relevant age groups. The calculation of chronic exposure concentration was based on the use of central tendency modeling inputs, including durations ranging from 10 minutes to 4 hours and for 12 or 57 years, depending on the COU. EPA applied an age-dependent adjustment factor, or ADAF, to cancer risk estimates to account for increased susceptibility to nasopharyngeal cancer following exposure during early life. ADAF adjusted lifetime cancer estimates are based on cancer and bystander central tendency exposure estimates. Next slide, please. This concludes my presentation of the formaldehyde consumer exposure assessment. Thank you for your attention, and I'll take any clarifying questions.
You're muted, Dr. Cobb.
Thank you for that presentation. Sorry, I thought I had unmuted and I had not. Thank you for that presentation, and we can go to questions now. Please do try to limit this to questions and not necessarily comments here, because we are still behind time. So thank you. Dr. Kim.
Yes, my question is related to the sources in consumer exposure assessment considerations. In the presentation slide, the sources are identified as articles and products. Under the current agency definitions, an article is defined as one having specific shape or design during manufacturing. Number two, end-use functions are depend on its shape and design. Number three, it does not release a toxic chemical under normal conditions of processing or use. So these agencies' current definitions of articles are consistent with most of the regional and country regulatory agencies' definitions, and are also aligned with the globally harmonized hazard communication system. So based on the definition of articles are not likely to release formaldehyde, or even though it's released, the amount is so minute. So it is not considered to be toxicologically significant to consumer health and safety under normal use and foreseeable misuse conditions. So is there any actually cases where certain category of articles used by consumers raise a concern? If that's the case, in my judgment, we probably need to define the articles on the task on FIPRA to be defined differently, or include exclusion criteria for articles. So when the risk make assessment and make a good
so Dr. Kim, you're getting into comments now rather than questions. So please confine this to questions.
Yeah, so my question is that, is there any cases where certain category of articles used by consumers raise a concern to be included in this case? Not just products.
So this is Giovanni speaking, Giovanni Marilis speaking. So in the CEM user guide, we define products specifically as consumable liquids, aerosols, semi-solids that are used for a given number of times before they are exhausted. Articles are generally solids, polymers, foams, metals, woods, which are always present within indoor environments for the duration of their use or useful life, which may be several years. We have reports in the literature that some articles do emit formaldehyde in the indoor air environment. So hopefully that helps to answer your question.
Thank you. That's
Thank
good
you.
answer. Dr. Ottinger.
Right. I can't start my video, but
Do not worry.
I'll ask the question really quickly. Oh, here we go. Thank you. And that is simply clarifying. In the case of something like textiles where somebody's wearing something that has formaldehyde in the finishing part of the product, is that part of the calculation? Because if I understood correctly, that was in the category of intermittent exposure rather than longer term.
Thank you for that question. This is Giovanni Meredith again. So if I could get some clarification on the question again, that'd be helpful.
Yep. I was just thinking that when you were explaining about intermittent exposures and the parameters surrounding that, textiles seem to be part of that, whereas more chronic exposures appear to be more through inhalation. And I was looking at the dermal transfer of formaldehyde products on the textiles that would be in contact with skin over long periods of time and how that figures in to the consideration of effects.
Right. So in the, this is Giovanni Meredith speaking again. In the consumer exposure assessment, we do provide a description of, we provide a qualitative assessment of potential exposure that may occur from textiles.
Right.
And the uncertainties surrounding that quantification of those exposures. So I would refer you to that, the appendices of the consumer exposure assessment for further clarification on that point, if that helps.
Okay. All right. Thank you.
Dr. Caden.
I apologize if I missed this, but you mentioning wood products made me think of this. Do you take into account that the formaldehyde emissions from some of these consumer products may be greater in the beginning and then as they off-gas decrease?
This is Giovanni Meredith speaking again. Yes, this is correct.
Thank you.
Right. Well, this is George Cobb. I actually have a couple of questions, and this is simply for clarification so that I don't make comments or so that I know how to address comments that come from the committee. So in your items or materials that are considered, liquid fuels was one of the things that was considered as a use. Was that limited to the formaldehyde that was in the liquid as constituted, or was that formaldehyde that might be produced during the use of the chemical or even secondarily after it evaporated or something of that nature? Did we lose Dr. Morales?
EPA?
Hello?
Yes, this is Giovanni Meredith. We're deliberating on that.
Oh, okay. If you would like, we could come back to that question at a later time if it's.
This is Giovanni Meredith speaking again. If we could come back to that question, that'd be helpful.
Yeah, that would be great. And we could come back to it during the consumer charge question portion even. But later today or then, either one. Now, I have a second question that was that combustion was excluded and the example was forest fires, but I want to make sure I'm clear. Combustion from things like trucks and transport or private vehicles or coal burning types of industries, those were excluded as well?
Yes, it's excluded. This is Giovanni speaking again. Yes.
Okay, thank you for clarifying those two questions. And then Dr. Chasen has one.
Hello, yes, perhaps there are a couple of places where I didn't exactly understand the mechanics or math that was being applied. And following up on the question where somebody said, well, the off-gassing at the beginning would be at a greater rate than later, that in my mind, I conjure up a distribution curve of some kind with a peak at the beginning and then tailing off across hours, days, months, years, whatever. Apparently, however, I can't find the page this was on, distributional analysis was not used. And so could you explain how you did take into account the difference that this kind of changing slope of off-gassing or on the other side, the difference in the air concentration contributions over time? Could you explain exactly how that was done?
Hi, this is Giovanni Meirelles again. We're deliberating on that question as well. One second.
Just ask her to wait.
This is Giovanni Meirelles speaking again. We can discuss the distribution curve further in the indoor air exposure assessment presentation.
Okay, I think that sounds good. And hopefully that's okay with you, Dr. Chasen.
Yeah, that's fine. Thank you very much.
Okay, so I think now we do go to the indoor air, which is actually Dr. Meirelles again.
Yes. Second. Okay, next we'll talk about the formaldehyde residential indoor air exposure assessment. Slide, thank you. I will begin with a brief overview of the formaldehyde indoor air exposure assessment. Then I will discuss various key sources of exposure, the approach for the indoor air exposure assessment, use of monitoring data such as the American Healthy Home Survey 2 to strengthen this assessment, consideration for pressed wood emissions. Lastly, I will cover how we apply the hazard and exposure estimates for risk characterization. Next slide, please. This presentation is structured according to Charge 5, whose relevant documents are listed on your screen. Next slide, please. Generally speaking, the residential indoor air exposure assessment for formaldehyde was composed of the key components listed on your screen. That is long-term formaldehyde off-gassing from particles, which is emitted to the air and subsequently inhaled in a house or vehicle. Next slide. Here is a diagram representing the residential indoor air environment. The residential indoor air exposure assessment was generated based on a few key assumptions. First, that this assessment is truly an assessment of multiple sources of formaldehyde or aggregate exposures over an extended period. This can be inferred from indoor air monitoring concentrations. Another assumption is that the most concerning exposures are likely from articles that are passively used and lead to significant or long-term emissions of formaldehyde according to the literature and professional judgment. Exposures from these articles were not primarily from active uses of consumer products, though modeled consumer exposures were used as a proxy for TSCA COU, or conditions of use, specific contributions of formaldehyde in indoor air. EPA also assumed that formaldehyde exposures in residential indoor air are likely higher than formaldehyde exposures in offices and schools, since air exchange rates in residences are generally lower compared to offices and schools. Therefore, the primary focus of this assessment, the indoor air exposure assessment, was on the residential formaldehyde exposures. The TSCA relevant articles applicable to this assessment include furniture, wood articles, hardwood floors, textile, wallpaper, and furniture covers. Next slide, please. EPA also considered formaldehyde inhalation exposures in an automobile environment resulting from the use of seat covers. Next slide. Exposure literature based on other sources of exposure were not in scope and therefore not captured during systematic review. As a result, EPA implemented a preliminary screen of open literature and governmental risk assessments to identify room concentrations from other sources of formaldehyde, which ranged approximately from 12 to 44 micrograms per cubic meter from modeled 50th percentile estimates for candles, incense, cooking, wood combustion, and air cleaning devices. We identified an average of approximately 13 micrograms per cubic meter for fragranced and non-fragranced candles, 3 and 39 micrograms per cubic meter for single burning incense, in a range of 2 to 25 micrograms per cubic meter of formaldehyde from air cleaning devices such as HVAC filters. Next slide, please. As previously noted in the presentation of the Consumer Inhalation Exposure Assessment, tables B4 and B7 in the CEM or Consumer Exposure Model User Guide appendices identify sources of key default parameters associated with specific products and articles. These primary sources are listed on your screen. Unlike the Consumer Inhalation Exposure Assessment, a few of these studies, contain emission rates which were incorporated into the model. Otherwise, the other data sources used for the indoor air exposure assessment remain the same compared to the Consumer Inhalation Exposure Assessment. Next slide, please. CEM was also used to assess residential and automobile indoor air exposures for formaldehyde. However, a few minor alterations to the model included the incorporation of article-specific emission rates for refinement and the focus on a one-year concentration average, given the lack of modeling certainty on indoor air exposure beyond that time frame. We will get into those uncertainties in a few slides. Next slide, please. Thank you. Residential indoor air exposures were estimated for 1 year of exposure, and in this example, we generate a chronic average daily air concentration for hardwood floors. Again, going in a clockwise fashion, starting on the bottom left of the slide, EPA selected a preset central tendency duration of 120 minutes or 2 hours, assuming that someone is at home part of the time or is a part-time worker. EPA assumed that the frequency of use would be every day for an entire year. The amount used was 200 grams per use. The consumer's exposure was used as a proxy for hardwood floor specific contributions of formaldehyde in indoor air. The weight fraction was 2.9% and the emission rate was approximately 12.7 milligrams per hour, according to the surface area expected to be occupied by that article in the living room. In all, the estimated concentration was 423 micrograms per cubic meter. Next slide, please. The indoor air exposure assessment is probably one of the most complex aspects of the formaldehyde risk evaluation. This is because there are several associated considerations and variables, for some of which we currently have data gaps. In this assessment, we generally assume that a new article is being used or added to the indoor air environment at some point of time. Though people often add and replace articles such as furniture for different reasons and at different frequencies. Generally, when a new article is added into the home, there is an initially high concentration, which is assumed to decrease significantly over time. If the same article, such as a seat cover, was added and replaced every 2 to 3 years, the contributions of formaldehyde concentrations to that residential indoor air environment might be represented in the figure to the right of the slide. This variability in replacement rates for one or more products could not be confirmed. We also do not know the lead time for the assessed articles. That is, the time it takes for the article to be created and delivered to the consumer's home. This along with the replacement frequency, dissipation, or emission rates depend on the article in question. A key thing to remember is that although CEM considers dissipation mainly due to ventilation, CEM does not consider chemical half-life. These uncertainties are likely compounded as we consider more than one source of exposure added simultaneously to the indoor air environment. Next slide, please. To strengthen its assessment of formaldehyde exposures in indoor air, EPA used a combination of modeling and monitoring data. EPA identified many indoor air monitoring studies used to contextualize formaldehyde indoor air exposures, as described in the residential indoor air module. Of these, the American Healthy Home Survey 2 was identified as one of the best available and recent monitoring studies of formaldehyde in indoor air. This survey was administered by the Department of Housing and Urban Development and the EPA. In general, our modeling estimates should not be directly compared with monitoring data. This is in part due to differences in what the exposure outputs represent. For example, the rooms of use identified in this survey varied from home to home. While only one room of use was assessed per condition of use in CEM, or the consumer exposure model. In addition, monitoring data from the American Healthy Home Survey 2, along with most other monitoring sources, do not and are not designed specifically to collect exposure data according to TSCA relevant conditions of use. Nonetheless, this survey provides us with an estimate of the total or aggregate formaldehyde concentrations from all sources at the time measured in typical American homes that are lived in, with concentrations ranging from 0.3 to 124 micrograms per cubic meter. Per the figure on this slide, 3 of the 4 modeled chronic average daily concentrations for 1 year are within that range, as indicated by the 3 stars, while the highest modeled concentration falls outside of that range at 423 micrograms per cubic meter for hardwood floors. Next slide, please. 2 wood articles were modeled for the indoor air assessment, including hardwood floors and wooden furniture. Despite potentially being made of composite or pressed wood, EPA did not have enough information to confidently quantify exposures from these products, specifically considering the emission rules that were set forth to reduce formaldehyde emissions from pressed wood. The emission literature and data found for pressed wood predate implementation dates. This means that the identified emission rates and weight fractions likely don't consider the emission standards for pressed wood. Therefore, to consider potential exposures from such sources, EPA conducted a qualitative assessment whereby it assumed that the emission standards for medium density fiberboard, particle board, and hardwood pressed wood were equivalent to an air concentration. This was used to generate a room and article-specific emission rate and the expected room of use, based on the specific surface area occupied by that article. CEM, or the consumer exposure model, was used to estimate the chronic average daily concentrations for 1 year using those emission rates. Results showed that while exposures to formaldehyde would be lowered in some cases, thanks to the emission standards, exposures would not be eliminated. Next slide, please. Regarding the application of the identified chronic inhalation non-cancer point of departure for the assessment of indoor air inhalation exposure, on the hazard side, EPA derived hazard values based on respiratory effects reported in epidemiology studies. These studies were primarily focused on effects in children following chronic exposure to formaldehyde in indoor environments. Characterization of the exposure durations in these hazard studies are somewhat variable across studies, but they are understood to represent chronic exposure. On the exposure side, exposures were assumed to occur to consumer article users. The calculation of chronic exposure concentration was based upon the use of central tendency modeling inputs, including durations ranging from 2 to 10 hours every day for 1 year, depending on the COU. Next slide, please. In summary, model estimated concentrations ranged from 4 to 423 micrograms per cubic meter. Compared to other articles assessed, hardwood floors were the highest contributors in modeled indoor air environments. Exposures are expected to be highest for new products or newly built homes or vehicles. Model estimated formaldehyde concentrations were within the same order of magnitude as measured concentrations from the literature. The identified TSCA COUs are important contributors to real-world concentrations of formaldehyde in indoor air. Next slide, please. Next slide, please. This concludes my presentation of the formaldehyde residential indoor air exposure assessment. Thank you for your attention, and I'll take any clarifying questions.
Thank you, Dr. Marilis. We have questions starting with Dr. Wolf.
Yeah, Doug Wolf, thanks for that really clear presentation. I did have one clarifying question. So on the Healthy Home Survey, is the assumption that any formaldehyde in the home would be due to any of the manufactured materials in the home? And I was wondering if these data exclude or account for homes with tobacco smokers and wood stoves, which are also sources of formaldehyde.
This is Giovanni Marilis speaking again. The Healthy Home Survey does do some delineation of the sources acquired or found in some of these homes, including wood stoves and other sources that may emit formaldehyde.
We have a question from Dr. Ockinger.
Quick question. Do you have any kind of distinction between the types of hardwood floors, meaning that, completely hardwood versus composite of various sorts? And are there any regulations for those? Regulations meaning, the emission standards applied to that.
This is Giovanni Marilis speaking again. I need a couple minutes to deliberate with my team on that particular question.
Okay, well, while we have a few minutes, I will say that in consultation with our DFO, it is possible that we will not get to public comments today. We're not going to preclude that yet, but that's a possibility, just so I've let everybody know. So let's go back to the agency for an answer.
We'll get back to you all with an answer on that question.
Could I ask one other piece of that question too, really
Sure.
quickly? Some of the floors are coated with a lacquer or some other sealant. And does that affect the emissions?
Yes, this is Giovanni Marilis speaking again. We recognize that as an uncertainty and as part of our assessment, we recognize that some wood products may have emissions coming from the glues, the laminate, the cover, the
right.
paint, in the wood itself. So that is a part of our uncertainties.
Thank you. And I keep forgetting this Mary Ann Ottinger asking the question. Thank you.
So next up, we have Dr. Bricey.
Yeah, hello, Pat Bricey. Thank you very much for your talk. So help me understand, if you can, the relative role of the model data versus the monitoring data from the housing survey. Was the housing survey data just used to kind of validate the modeling data to show that it was roughly, or did you use those two as two separate inputs into some sort of risk assessment? How did you wield those two sets of data that tell you about indoor air concentrations?
The modeling and the monitoring data were used together to improve the characterization of the indoor air environment. Does that answer the question?
I guess I'm not sure how. So you model something, and then how would you know whether to use the model data or the monitoring data? Or I just have a hard time seeing how they were used together or separately, or yeah, just not quite sure.
I have a quick question. Clarification on the use for what exactly? I'm sorry.
So on one hand, you have indoor air measurements. On the other hand, you have the modeled indoor air concentrations. When would you use a modeled estimate rather than the measurement data? Or when would you use a measurement data rather than the model data? Or how did you, I'm not quite sure how you would possibly combine the two into, because they're separate measurements. So how you're using them is not clear to me.
Sure. This is Giovanni Merli speaking again. So as I've mentioned in the presentation, most monitoring studies are not TSCA COU specific. And the models allow us to be able to assess potential exposures from specific conditions of use that contribute to the indoor air concentrations of formaldehyde. And that's why we use both the monitoring and the modeling.
Well, that I get. You don't need the monitoring data to do that if you have the model data, right? So if you're just doing TSCA specific assessments, then what's the role of the aggregate air monitoring data, which isn't TSCA specific? If this is better covered, when we get to this section, I don't know, but I was just looking for kind of what the relative use of both of those were.
Yeah.
This is Susanna Wegner from EPA. I think just to clarify, this is partly addressed in aggregate, but also the way we characterize it in the assessment is just to describe the monitoring data as a reflection of the aggregate of all of the sources that contribute to indoor air, so that we can understand what the total exposure is in any indoor air environment. The problem is that in application in TSCA, we need to also understand the individual contributions of the TSCA COUs. So it's a question of understanding what is the big picture aggregate story of indoor air in general versus what is the individual contribution of individual COUs. Does that?
Okay, so it's context is what you're looking for the air monitoring data to provide.
That sounds right. Yeah.
Okay, thank you.
Okay, we have a question from Dr. Chase.
Thank you. EPA, in the document, the draft indoor exposure assessment on page 22, table 3.2, the very first line where you're talking about, in the table, it talks about the American Healthy Homes Survey. It shows a mean of 23.2 micrograms per meter. And then next to it, it says the range or percentiles, I'll quote this, range, lower upper 95th percentile of the mean, 21.4-5.0. Could you explain that? I don't understand what that, I don't understand. It can't be a range, and I don't know what the It can't be the upper 95th percentile of uncertainty. So I don't know what those numbers are.
Is that, I'm sorry, is that a particular slide number, Dr. Chason?
It's in the text. It's when they're talking about the American, this is in the text, page 22, line 520. And it, I mean, he just pointed out the use of the numbers, but I don't get it. I might be missing some very basic statistical point, but I don't know what that means.
This is Giovanni Marilis again. We can follow up on that question.
Okay, and maybe it's a typo, or maybe I just don't understand what you're trying to present. Okay, thank you.
All right, well, at the risk of making things go even longer, I think this is a cascade. This is George Cobb speaking. I think this is a cascade from the last question, but I'll just ask so I'll make sure I understand. In your indoor assessment, there was no inclusion of formaldehyde release from propane or natural gas cooking. Is that correct?
This is Giovanni Marilis speaking again. Yes, that's correct.
Okay, thank you. All right, with that, I think we are at maybe a break time. Well, yeah, what do you think, Ms. Gibson? Do you think it's time for a break, or should we go through the next presentation?
I think we can break. We have allocated 40 minutes for the next presentation, so we can break at this point.
And should we take 10 or 15 minutes?
15.
Okay, let's take a 15-minute break, and I apologize for the rattle in the background. There's construction in our building, evidently. So, see you folks soon.
Okay, great. Thank you. It'll be 3:30.
Yes, ma'am. Right. Welcome back to this later afternoon session of the formaldehyde review. So we left off with, this is George Cobb speaking. We left off with our questions for our EPA presenters, and now I think it's time to hear about the analysis and interpretation of ambient air monitoring data from Mr. Is it Groza?
Yeah, that's correct. This is Brian Groza.
All right. Well, we're looking forward to hearing what you have to say.
Hi, so I'm Brian Groza, and I'm a physical scientist in the Existing Chemicals Risk Assessment Division, and I'll be presenting on the draft ambient air assessment for the formaldehyde risk evaluation, and especially those methods that are relevant to charge question number 6. Next slide, please. So here's a quick outline of the ambient air pathway presentation. First, I'll provide a brief overview of the ambient air pathway. Then I have a series of slides that summarize the Ambient Monitoring Technology Information Center, or AMTIC, data that we used, and also the application of the Human Exposure Model, or HEM, to characterize the aggregate exposures. These two sources of data allow us to consider exposure to formaldehyde from multiple sources that can include TSCA COU and other sources. The HEM also provides spatial exposure characterizations on a site-specific basis, so we'll discuss that. And then I'll summarize the use of the 2019 air tox screen results. And lastly, we provide an overview of how we applied the hazard data and exposure estimates for risk characterization, as in the other sections. Next slide, please. So here's that document map again to orient you and focus your attention on the relevant documents. This includes the draft environmental release assessment, the draft human health hazard assessment, the draft ambient air exposure assessment, and the draft human health risk assessment. They are highlighted in blue on the left, and there are some links on the right. Next slide, please. So first, I'd like to introduce the considerations EPA includes within the ambient air assessment. In particular, the ambient air assessment for formaldehyde focused on industrial releases of formaldehyde to the ambient air and the inhalation route of exposure. The exposed population considered is a subset of the general population who live nearby those industrial facilities releasing formaldehyde to the ambient air. Next slide, please. So EPA expects the ambient air pathway to be the predominant human exposure pathway to formaldehyde in the outdoor environment, which is visualized in this slide. In summary, formaldehyde is released from industrial facilities as uncontrolled fugitive releases, for example, process equipment leaks, process vents, through building windows, building doors, and roof vents, and also as stack releases that may be either uncontrolled, for example, direct releases outside of a stack, or out of a stack, or controlled with pollution control devices like a bag house, a scrubber, or thermal oxidizer. Once released to the ambient air, formaldehyde may move off-site into the surrounding areas where humans may be exposed through inhalation. Again, this draft ambient air exposure assessment focuses on exposures to a subset of the general population living nearby industrial facilities that are releasing formaldehyde to the ambient air. Next slide, please. So this slide visualizes the ambient air pathway methodology and data sources used in the formaldehyde risk evaluation. It also shows the various models used and how the respective data were applied in the evaluation for formaldehyde. EPA used the monitoring data from the Ambient Monitoring Technology Information Center, or AMTIC, to get an understanding of how monitored formaldehyde concentrations vary across the United States. This is highlighted at the top of the slide. These data represent an aggregate or total exposure to formaldehyde from all sources of formaldehyde, including natural and man-made sources. EPA used multiple data sources, including multiple years of data from TRI, and multiple models to estimate concentrations of formaldehyde in the ambient air. This is illustrated on the bottom part of the slide. The focus of our charge is specific to the use in our interpretation of the AMTIC monitoring data, the use and interpretation of the air tox screen data, and HEM modeling. EPA is not seeking feedback on the use of IIOAC since the model and methodology have been previously peer-reviewed by the SACC. Next slide, please. So as mentioned, OCSPP evaluated monitoring data from EPA's Air Monitoring Technology Information Center, AMTIC. This data set includes approximately 234,000 formaldehyde field samples collected by state and local agencies around the continental United States from 2015 to 2021, which is shown on the map. Sample collection durations for formaldehyde data range from 5 minutes to 24 hours in this data set. These data were collected and quantified using methods pre-approved for formaldehyde air measurements by AMTIC. However, the sampling sites were not specifically selected to target formaldehyde sources or TSCA COUs. These data are considered by EPA to represent real-world formaldehyde air concentrations. EPA recognizes these data represent total aggregate exposures to formaldehyde from all sources of formaldehyde around the monitoring site. These sources are expected to include TSCA sources as well as other sources. So some locations may be nearby one or more industrial facilities releasing formaldehyde and thus could represent concentrations associated with a TSCA COU. Next slide, please. Several steps were taken to filter and process the AMTIC data to account for incomplete and missing data, including any entries to AMTIC that were missing key information were not used in subsequent analyses. Missing information that limited the use of the data included method detection limits, collection methodology, analytical methodology, concentration units, or geographic information. And entries reported to AMTIC with concentrations below the respective method detection limit were assigned a value of 0 micrograms per cubic meter using the zero substitution method. The final data set contained approximately 199,000 monitoring samples with 35,000 data points removed due to data issues. The figure here shows the distribution of samples and sites with respect to sample collection durations. The sample duration is listed on that vertical axis, and the horizontal axis represents the total number of samples for each duration. The number of sites is represented by samples, and the number of sites is represented by the number in the box at the end of each duration category. All sample durations were equally treated, assuming continuous release of formaldehyde. The data were not processed further to estimate exposure over longer durations. So next we'll take a look at the modeling of releases to the ambient air from facilities that was conducted by EPA with the HEM model. Next slide, please. So EPA's human exposure model, or HEM, version 4.2 was used. The HEM relies upon facility-specific location and release data and applies localized meteorology, topography, and population information to estimate ambient air concentrations of modeled pollutant and population impacts. This figure here is a visual example of one releasing facility surrounded by a cloud of receptor points. For each individual facility, a series of radial distances and census block centroids are applied as receptor points where ambient air concentrations are modeled. In addition to individual facility concentration results, the HEM provides aggregated concentrations for multiple nearby releasing facilities. And information about the populations and demographics in the areas with elevated concentration estimates is also provided in the risk evaluation. Next slide, please. The geographic data that accompanies the modeled release information and concentrations allows the HEM results to be visualized on a map. This map shows the range of modeled concentrations resulting from TRI reported releases as output by the HEM model on a map of the continental United States. The map shows that nearly every state contains facilities reporting formaldehyde air releases to TRI. The highest concentrations of facilities appear to be more densely located in parts of the Southeast, Midwest, and in the Pacific Northwest. These results can also be used with the census data to understand populations impacted by the estimated concentrations. So next, we'll review the application of the air tox screen data. Next slide, please. Thank you. The 2019 air tox screen results show the modeled range of formaldehyde concentrations in the ambient air from a range of source types. This plot shows in orange the total distribution of air tox screen results, as well as the point sources, which were expected to more closely relate to the TSCA COUs, but can also include other sources of formaldehyde not attributable to TSCA-specific COUs. It shows the biogenic or naturally occurring sources and the secondary sources, that is, atmospheric formation of formaldehyde as a degradation or reaction product from other naturally occurring or synthesized compounds. These concentrations are based on releases modeled from NEI data summarized to a census tract scale. Note that a census tract is much larger than a census block, and this results in lower averaged concentrations than the finer resolution modeling of discrete distances and census blocks conducted by EPA for this risk evaluation. While other source types are not shown on here, like residential wood combustion and point source airports and oil and gas, some of those also have higher contributions compared to remaining source types. And they're associated with combustion products and thus not considered in scope for this formaldehyde risk evaluation. At the top of the plot, we also show the distribution of AMTIC monitoring results and EPA's IIOAC model results from facility releases. The air tox screen data were applied in the risk evaluation to contextualize the model release data. Differences in the modeled results, such as the larger spatial scale and a broad inclusion of sources that are not necessarily relevant to TSCA COUs, limit some of the direct comparisons that can be made between the air tox screen and other modeling sources used in this ambient air assessment of formaldehyde. Next slide, please. EPA is seeking SACC review of our application of the IRIS hazard values to assess each pathway. Regarding the application of the chronic inhalation non-cancer point of departure for the assessment of outdoor air exposure, on the hazard side, EPA derived hazard values based on respiratory effects reported in epidemiology studies. These studies were primarily focused on effects in children following chronic exposure to formaldehyde in indoor environments. On the exposure side, we assess continuous chronic exposures for people living near release sites. Exposure estimates are based on 95th percentile air concentrations, modeled based on 95th percentile releases for each industry sector. Next slide, please. Regarding the application of the identified cancer inhalation unit risk, or IUR, for this outdoor air assessment, on the hazard side, the basis for the IUR are nasopharyngeal cancers in an occupational cohort. IRIS adjusted this IUR to reflect continuous exposures. For the ambient air exposure assessment, exposures were assumed to occur to populations living nearby releasing facilities, including children. The calculation of chronic exposure concentration was based upon the use of the 95th percentile release and the 95th percentile exposure modeled concentrations by industry sector, assuming continuous exposure for 78 years residency and 78 years life expectancy. EPA applied an age-dependent adjustment factor, or ADAF, to cancer risk estimates to account for increased susceptibility to nasopharyngeal cancer following exposure during early life. Next slide, please. And with that, I thank you for your attention, and we'll take any clarifying questions.
Thank you.
Dr. Cobb, may I make a statement?
Certainly.
Quickly for those public commenters who plan to make a public comment. We may not get to make plan for public comments today. The approximate time was at 4:20 today. We still have additional presentations. So for those commenters who are arriving into the Zoom, we will most likely begin public comments on tomorrow morning at 10:20. I'll make another announcement before the end of the day.
Yeah,
Thank you.
Thank you, Ms. Gibson. And I think that's probably where we're going to be, is no public comments today. So we'll have a question from Dr. Chase.
Thank you. First of all, my question at the end of the last presentation, maybe I should have directed that question to you for this section, for the looking at the ambient air monitoring. I'm not sure where that actually belonged, but anyhow, the question that I have for this section was, in the modeling for the site-specific releases, where the TRI reported formaldehyde releases, or those you call fugitive releases, were the formaldehyde releases from the manufacture of formaldehyde, or the use of the formaldehyde, or from formaldehyde as a component of a product being made there, or other reasons? Does it matter why the formaldehyde was being generated and accidentally released?
So this is Whitney Hollinshed from the EPA. So with the TRI covers mostly industrial uses of formaldehyde. So they could be manufacturing formaldehyde. They could be using it for other industrial uses. TRI has its own requirements as far as whether a facility has to be required to report to TRI. But most of it covers industrial conditions of use, not necessarily commercial uses of formaldehyde. Does that
right? Well, I'm assuming, and I actually went to TRI to see if I could find this, but did it matter to EPA? Why, was it coming as a byproduct of whatever it was they were doing inside the industry? Does it matter to EPA why the formaldehyde was, say, in the stack to begin with?
So this is Whitney Hollinshed from EPA. So we do desire to look at what condition of use the facility fits in. So for formaldehyde risk evaluation, and this is covered a lot in the environmental release assessment, we did a different approach with formaldehyde because of the amount of data we had between TRI and NEI. We looked at the industry sectors. So you'll see in the IIOAC analysis, you'll see that's an industry sector analysis. And basically, we looked at a particular industry and we related that back to the conditions of use that industry has reported to us that they're using formaldehyde in.
Okay. Well, if it doesn't, if it doesn't require that formaldehyde was part of the formaldehyde containing product or some other kind of rule, the kind of logic that you used, then consider this. I'd like you to comment on this. Essentially, the formaldehyde being generated or for some reason becomes fugitive is essentially what's, in my mind, happening on a highway. There are homes and schools and businesses around roadways, and there are vehicles which are generating fugitive release, if you will, of formaldehyde in that corridor. And the kind of site-specific GIS-enabled assessment that you did for the TRI emissions could be done for mapped major roadways, along with release rates for per vehicle type, and those data are indeed available. So could you explain why the logic of the roadway is so different from the idea of what you did with fugitive releases from industry?
Already on unmute. This is Whitney Hollinshed from EPA. I mean, I think we will feel like we did kind of address this on the vehicle exhaust, but if you want to add it into a comment or for during the charge, I think we can address it then.
All right, thank you.
So yeah, I think that's probably coming in the charge question on conditions of use. That's
Okay.
probably a good place for that.
Okay, sorry if I treaded over that.
No,
line,
that's,
George.
it's good to ask the question. And thanks for the answer as well. It's George Cobb speaking. Our next question was from Dr. Wolf.
Just a clarification, this is Doug Wolf, a clarification on the aggregate exposure from, so were non-CO conditions of use sources such as forest fires, which have been substantial in the Western US, removed from the data? Just wondered when you discuss the aggregate exposure, those can be pretty substantial in some areas.
Yeah, this is Brian Groza from EPA. The aggregate exposure that I was referring to on those slides with the HEM modeling, that was strictly due to TSCA COU releases from facilities where there were multiple nearby facilities. Those concentrations and exposures were aggregated.
Okay, thanks.
Okay, next I think we have Dr. Henneman.
Hi, thanks, Lucas Henneman. Just clarifying question, the plot showing the distributions on slide 107 from AMTIC, IAOSC, and AirTalk screen. I wonder if is there an effort made to harmonize the locations or time? I know that times modeled are relevant for some of these models, but not for others, but is there an effort to harmonize the time compared between these two models, and what does the N represent on the y-axis of this plot? The two questions.
Okay, so this is Brian Groza with the EPA, and that N count are the total number of samples for each of these data sets, or data points, I should say. For the AMTIC monitoring, those would be sample counts. For the IIOAC, those were modeled industry sectors. And for the AirTalks screen results, those are census tract averages. So these are happening on a different spatial scale. As we mentioned, the AirTalk screen, this is a concentration that's averaged across a census tract, whereas the IIOAC would be modeled at discrete distances, such as 100 meters or 1,000 meters from the releasing facility. And the AMTIC monitoring sites are just points of sampling that are not necessarily attached to facilities that are releasing formaldehyde.
Got it. Thank you.
Our next question is from Dr. Fox.
Hi, yes. So I think you mentioned when you were talking about the AMTIC data that it may reflect specific facilities. But I was thinking about the maps that you showed. I mean, was there an attempt to do sort of that, I don't know, a correlation analysis with specific facility locations to kind of, to get a sense of that overlap or that specific spatial relationship?
Hi, this is Brian Groza again with EPA. For this draft, we did not complete this kind of analysis to answer that question.
And then Dr. Caden.
Thank you. Clarifying question. Do you ever ground truth modeling data with monitoring data? And I'm specifically thinking about AirTalk screen, where you may get different results from year to year, and you might want to understand why the results are different.
I think they're conferring.
Hi, this is Brian Groza again with EPA. So that is what we are attempting to do with this data, to provide context and some ground truthing, but we do recognize that there are different spatial and temporal scales for these modeled and monitored data sets.
Thank you.
Are there other questions from the committee? Well, I seem to be the fly in the ointment here, but I'm leaving my questions for last. I have two questions. First of all, you mentioned the limits of detection were set to 0 instead of some other value between 0 and the limits of detection. I guess the first question is, why choose 0? And does that influence your ultimate statistics, i.e., were you looking for centile values, or were you looking for concentration means, or those kinds of things in this evaluation? In one case, assigning the 0 matters, and in the other case, it maybe does not.
Hi, yeah, this is Grant Yejin from EPA. So we did actually attempt to do multiple substitution methods. So we looked at 0 substitution, half MDL root 2/2 times MDL, as well as MDL itself substitution. The reason we chose 0 substitution is largely because of the differences in analytical methodology used, because these are not standardized to one acquisition method. They have various methods submitted from state and local agencies that can have varying levels of accuracy and precision. And so it was, that can range several orders of magnitude depending on the accuracy of the specific method. So it was an attempt to, instead of go piecewise and point by point, to just do a single standardized method that is generally accepted across all data points. So there's no kind of picking and choosing. So it's equal treatment. In terms of the second question, that might be better answered by Kevin Villemere. Kevin, do you have a response for that one?
This is Kevin Villemere. I'll ask to kind of clarify what the second part of the question.
So basically, if you have low limits of detection, how you assign a limit of detection shouldn't matter. But I'm just hearing, which I kind of thought, and I appreciate the open answer, is that you've got a wide range of limits of detection. So how you assign those can change where a data point fits or what your mean turns out to be, because you may get very largely different answers from one limit of detection versus another. So the question then was, do you get different results if you assign the limit of detection versus 0, or half the limit of detection, or square root of 2 divided by the limit of detection divided by that, or some distributional insertion technique for assigning those limits of this? Do you get different outcomes from the value, the concentration value that would go into the risk assessment.
I'll defer back to Grant to respond to that. It's still getting to the analyses that we did, and it sounds like your question really is, first, did we consider multiple results? For example, we did zero substitution. Did you also do half? Did you also do square root? And then by doing that, what was the outcome? And I defer to Grant to kind of come out with if there were differences, as you're describing it, Dr. Cobb, in the different ways to approach it. Is that what you're asking?
Yes, and I didn't necessarily ask if you did it. I just asked, would it logically or likely affect the outcome?
Okay. Yeah, Grant, go ahead.
Yeah, so that I can kind of expand on a little more. Generally, depended on the actual acquisition method, kind of like I alluded to before, they have a very wide range of method detection limits that were reported. We did do a direct comparison of the results with the different substitution methods, and largely we didn't see any major differences, at least with respect to the mean and median that we used to ground this model. The only exception to that was when we used the worst case scenarios, the direct MDLs, and we decided not to go along with that just because there was such a large range and relatively little documentation to go with how those MDLs were calculated. Does that answer your question?
That answers my question perfectly, and I appreciate it. And I know that's a tough question, and it's a tough thing to have to deal with. So I appreciate you addressing it both in preparing the report and in this session. Oh, I have a real statistician who's going to ask a similar question, perhaps, Dr. Landis.
I would never call myself a statistician, but I use statistics. There's a big difference. Wouldn't these models apply to receptors other than humans that were in a similar region, even if some of the habitat characteristics may be different? When these kinds of models also apply to non-human receptors as far as exposure? Okay.
I think we're trying to find the right person. So
Okay.
that's a great question.
Yeah, we do this for air pollution monitoring in the Northwest because we look at a variety of receptors there. But this is different.
Hi, this is Brian.
Are you there, Brian?
I can hear you now. Yeah.
Yeah. Hi, this is Brian Groza with EPA. Yes, we understand that this exposure could also happen for other organisms. We did not include the ambient air modeling in the ecological exposure. And this is
Right. Yeah. That's what I kind of expected, but I'm not an expert, and I wanted to confirm that. Thank you very much.
Okay, and this is my last question, at least on this one, I promise. And if the answer isn't right away, that's okay. We've heard several times certain conditions, certain uses aren't part of the TSCA conditions of use. And my specific question is, where in EPA are the fuel and fuel combustion uses or productions considered as part of the formaldehyde risk, overall risk determination that EPA is doing, if it's being evaluated, if that aspect is being evaluated at all?
Anna Lowett, OPPT Science Advisor. So, Dr. Cobb, can you ask us the context that you're looking for that information for? Are you asking us to engage with a collaboration, or are you thinking we?
So formaldehyde combustion and formaldehyde used in fuels or formaldehyde content in fuels is used in commerce, and if it is not being assessed somewhere else in EPA, it needs to be assessed by TSCA. So that is the context of my question. So the context is, the question is, are fuels and fuel combustion being the formaldehyde content in fuels or the formaldehyde discharge from combustion of fuels being considered in the formaldehyde risk assessment that EPA is doing? By other brands.
All right, hi, this is Rochelle. I'm going to turn on my camera.
Okay, great.
Great, thank you.
Yeah, so Rochelle Bohati with EPA. So for the purposes of this TSCA draft risk evaluation for formaldehyde, EPA considered these as background exposures that are accounted for in the outdoor and indoor air exposure assessments.
No, you did not. You excluded them from the outdoors assessments.
Yeah, I think that by background, we're associating that with the concentrations associated with what we're calling background.
What I'm saying is I don't consider those background, and is anyone else within the EPA besides TSCA evaluating fuels or fuel combustions as a source of formaldehyde in the risk determination process or risk assessment process? And if you don't have an answer for that today, it's okay. We can come back to it a different time when we're talking about conditions of use.
Anna Lowett, I think we're going to have to get back to you. We're going to need to check in with some other people related to the role of other offices and formaldehyde. I mean, it's a complex regulatory structure. So we'll get back to you.
Understood. The thing I don't want to do is have a lot of text that speaks to that if it's being done somewhere else, and we can say, hey, this is being done somewhere else. We don't need to think about this within the TSCA framework.
Understand.
That's what I'm trying to avoid, frankly.
Understand.
Yeah, I haven't said it this time. I usually say it a lot. I really am trying to help the agency get through these, not make it more difficult. So if it seems like I'm trying to make it more difficult, I'm not. Okay, I think that's all the questions, and we now would move to the aggregate exposure aspect, and that's Dr. Boulomere.
This is Susanna Wegner with EPA, and I'll be presenting the aggregate.
Okay, great.
So I'm a toxicologist at EPA. I'll be providing an overview of our consideration of aggregate exposure and risk. Next slide, please. So this is discussed in section 4.3 of the Human Health Risk Assessment and is the focus of charge question 7. Next slide, please. In this section, I'll review the levels of aggregation that we consider, and I'll discuss how we handled each of them in the context of formaldehyde specifically. Next slide, please. So EPA considers several levels of aggregation in TSCA risk evaluations, and the decision whether EPA pursues quantitative or qualitative consideration of each level of aggregation is based on chemical-specific information. EPA is iteratively refining our aggregation approaches, and our primary aim at this point is to clearly communicate the rationale for the approach that we take and to articulate any uncertainties associated with our approaches for formaldehyde. And we are welcoming your comments on this. In general terms, OPPT considers several potential levels of aggregation in TSCA risk evaluations. We consider aggregation across exposure routes. This refers to exposure through oral, dermal, or inhalation routes. For example, a worker may have both inhalation and dermal exposures to a given chemical. We also consider aggregation across multiple sources contributing to a pathway. For example, if there are multiple facilities releasing to ambient air. EPA also considers aggregation across pathways. For example, if there are exposures through both air and water, we consider whether it is appropriate to assess those exposures together. And then finally, we consider aggregation across exposure scenarios. For example, if an individual may be expected to have exposure at work as well as through sources that are present at home, EPA considers the extent to which we have evidence that some of those specific exposure scenarios that we assess independently may co-occur for some individuals or groups. So although EPA is still in the process of defining a consistent set of rules for determining how and when we consider each type of aggregation in the context of different chemicals that we assess under TSCA, with each new assessment, EPA is making incremental progress and testing new approaches to consideration of aggregate. And feedback that we receive on our approaches as applied in the context of specific chemicals can help shape EPA's broader decision-making framework for considering aggregate exposures in the future. So for formaldehyde specifically, we consider each of the 4 levels of aggregation as discussed in section 4.3 of the Human Health Risk Assessment document, which is document number 13. And briefly, the formaldehyde assessment includes quantitative consideration of aggregation across multiple sources contributing to the air pathway for both indoor and outdoor air. Aggregation across routes, across pathways, and across exposure scenarios were considered qualitatively. And we'll talk through each of these in the next few slides. Next slide, please. EPA qualitatively considered aggregate exposures and risks across inhalation, oral, and dermal routes of exposure. For formaldehyde, cancer risk is only quantified for inhalation exposures and therefore cannot be quantitatively aggregated across multiple routes. Non-cancer risks for formaldehyde are highly route-specific, and each route-specific hazard value was based on effects that occur near the portal of entry. And because the non-cancer effects are specific to the route of exposure, EPA concluded that the non-cancer risks are not expected to be additive across routes. Next slide, please. EPA also considered aggregation across pathways of exposure. However, for general population exposure, we only evaluate exposure via the air pathway. So there are no other pathways to aggregate with. In addition, because EPA determined that risks are not additive across routes, EPA would not aggregate exposure and risk across pathways for which exposure routes are not the same. So for example, EPA did not aggregate inhalation exposure through outdoor air with dermal exposure associated through use of consumer products. Next slide, please. So we'll turn now to aggregation across multiple sources contributing to exposure via a particular pathway. EPA considered the combined exposures that may result from multiple sources releasing formaldehyde to air in a particular indoor or outdoor environment. In this case, indoor and outdoor air are the primary pathway we focused on where multiple sources may co-occur. And as you have heard already from Gio and Brian, monitoring data for formaldehyde is the best available indication of aggregate or total exposures that occur in indoor or outdoor air under a range of real-world conditions. As described in section 4.2.3 and section 4.2.4.1 of the draft Human Health Risk Assessment, EPA considers the range of risk estimates based on monitoring data to provide an estimate of the range of risks from aggregate exposures in air. However, risk estimates based on monitoring do not provide information about the relative contributions of different sources. So EPA used COU-specific modeling to understand the individual contributions of specific TSCA COUs. Next slide, please. So EPA therefore also evaluated aggregate risks based on modeled air concentrations for multiple TSCA sources releasing formaldehyde to outdoor air. And that's in section 4.2.4.2 of the draft ambient air exposure assessment for formaldehyde. I'm sorry, 4.2.4.2 of the risk assessment, and it's also in the draft ambient air exposure module. You've already heard from Brian on this earlier today, presenting on the HEM analysis, which considers the combined impact of multiple facilities in proximity on formaldehyde air concentrations at a particular location. And this analysis includes facilities from all TSCA COUs that are present in a given location. For indoor air, the agency qualitatively considered aggregating air concentrations estimated for plausible combinations of COUs expected to co-occur in specific indoor environments. So for example, combinations of products likely to be present in mobile homes, new homes, or automobiles. But this was a qualitative discussion. Next slide, please. Finally, EPA qualitatively considered the aggregate exposures individuals may experience from multiple exposure scenarios. For example, individuals exposed to formaldehyde through work or through use of consumer products are expected to also have exposure to formaldehyde through outdoor air and/or indoor air. In the case of formaldehyde, EPA concluded that there are uncertainties associated with the quantitative aggregate analysis, and this analysis was limited to qualitative consideration. Next slide, please. So that concludes our summary of aggregate considerations, and I'd be happy to take clarifying questions.
Thank you. Are there questions from the committee? Dr. Land.
Thanks. I always like hearing about uncertainties. They're the bane of my life. In your case, you said there were uncertainties, but you didn't describe what type. And of course, there are multiple types. And then you said that there are too many uncertainties and therefore you do a qualitative analysis. Often I'm not sure if the uncertainties are too great until I actually attempt a quantitative analysis first, and then see where the distributions are off or something like that. Did you guys perform such an analysis first and then resort to a qualitative approach? That's my first question.
Anna Lowett, thanks for the question, Dr. Landis. So as a matter of sort of practice, EPA practice, we first do individual pathways and routes, and in this case, COU, and look at the information that we have and the methods that we've used, and then decide when to aggregate and when to not. And so in the case of formaldehyde, as you've seen, as we've gone through the day, we have a large number of technical questions about our data, the data we've used, our data analysis approach, the models, our interpretation of those models, and that includes both hazard and exposure. Okay. And so it's, although one can take an exercise and start adding up numbers, we first need to make sure that the foundational analysis of the methods and models and data interpretation is sound before we start thinking about how to combine them or how to interpret information from models that combine routes in combination of monitoring data that we know is coming from multiple sources, both TSCA and not. So we have talked about adding up those numbers, but we know going into it that we have a bit of uncertainty, and we're really looking forward to input from this panel on our methods and data analysis.
Here, one of my suggestions is those exercises are sometimes useful when you do a sensitivity analysis and find which one of the uncertainties are knocking you back. But it sounds like your epistemic uncertainty is so large that it's very hard to know where to begin. So. that's-
Anna Lowe, I think that's a true statement.
Yeah, yeah. The second question is somewhat related, but I've been listening to the aggregation and so forth. Have we talked at all about agricultural receptors and who's responsible for those? Because so many of these plants and so forth can be in areas that may be somewhat urban, but also have also can be in places with large agricultural livestock and so forth, potential receptors. Is any of that part of this scope? And if not, what agency, what part of the government actually covers that? I know in California and Washington, two of the largest industries are agriculture, even though they're known for other things. And I often get those questions more from rural counties rather than or more urban areas.
I can try to answer that a little bit, Dr. Landis. So, excuse me.
That's fine. Yeah, it's a long day too.
One more.
That's fine. I also get hay fever, which is very annoying at times.
So maybe we can come back to that. You okay?
That's fine.
I think I'm good. Sorry, I nailed too fast there. We do have terrestrial receptors in the environmental risk characterization. So you'll see plant hazard values and inhalation values from human health models, but that way we compared with ambient air concentrations in qualitative screening.
Right, but that said no risk.
Correct.
But here we're showing exposures.
Yes.
So there's
Yeah.
okay. That I'll be absolutely sure I have this correct. All right. Thank you very much.
So Dr. Ottinger.
Just following up the same path as Wayne's first question, I was wondering if there was any kind of weighting potentially that could be done. I know Cynthia Stahl and others have used various methods to give the different pieces, if you will, of the puzzle different weights to attempt to provide a realistic view of the interacting and complex factors that are involved here. So I'm thinking in particular of, the inhalation being the primary route. So would that be weighted more heavily than other routes of exposure?
Dr. Anna Lowett, so question for you, Dr. Ottinger, how would you I guess the question back to you is for clarification is,
right,
what would those methods be used for in this case?
So this is Marianne Ottinger. I was just thinking that with all the different aspects that we've been hearing and the uncertainties that are present and the primary routes of exposure being, inhalation as well as dermal, let's say, is it useful to attempt to clarify the risk based on what the most likely routes of exposure would be or the most likely physiological outcomes? And I didn't know if that was part of what would be done here. So sorry, my question's so vague. I'm familiar with Cynthia's work where she had lots of different multiple inputs into a system that had different effects at various levels. And so she had a nested kind of approach to sort that out.
It sounds like something that may be useful in your comments back to some of the questions.
Okay, I'll be glad to provide that. Thanks.
Thank you. So I see Dr. Rubin has her hand up.
Hi, Rainbow Rubin. Can't get my video on. But I just wonder if you could, oh, here we go. Okay, thanks. I just wonder if you could walk us through how EPA determined that effects aren't additive one more time. That slide went a little fast for me.
Sorry, I turned on my camera, but not my sound. This is Susanna Wegner from EPA. And I can walk through that again really briefly. Generally, our rationale on the routes, consideration of aggregate across routes was that on the cancer side, we're only assessing one route to begin with. We don't have a quantitative analysis for cancer for routes other than inhalation. On the non-cancer side, the hazard values that we have identified for each route are based on effects that are highly route specific. So the inhalation POD and hazard value are based on respiratory effects and eye irritation. The dermal effects are based on dermal sensitization, and the effects following oral exposure are based on a gastrointestinal effect. So for each route, the hazard is driven by an effect that occurs near the portal of entry. And so based on that, we concluded that those effects are not inherently additive, but we welcome comments on that.
Yeah, even though the eyes and the nasal passages and the skin are all in pretty close proximity, so no one could justify adding based on that. Also, just a quick follow-up question. You also mentioned the methodology for aggregation is an iterative process, and I wonder if anybody can expand on that. I know in the last SACC meeting on 1,4-dioxane, there was a request for more quantification regarding aggregation, and it looks like these analyses were conducted similarly. So I just wonder if there's any more information you can give us on that iterative process to request more explicitly the quantification.
Yeah, thanks for that question. So in the case of 1,4-dioxane, we received your comments. We have been considering them as we make revisions. And in this case, each chemical has a slightly different situation in terms of what the hazard profile looks like and the nature of, whether the effects appear to be systemic versus not systemic, and the degree to which, if for each chemical, we just have a different set of context to work with. And so our aim is that as we work through individual chemicals and consider an appropriate approach for an individual chemical, that over time that builds into a consistent decision logic that helps us make chemical specific decisions that are rooted in a consistent logical framework. So each chemical will have a different approach, but the root of our rationale will be consistent as we move forward.
Thank you. Thank you for that answer and the question. So I see Dr. Heiger-Bernays has a question.
Thank you. I have two questions. One is an extension of Wayne Landis's question, I think. The term that's used in the document, but I don't know that I heard it here, is...
Can you speak up just a little bit? We're having a little bit of hard time hearing.
Yes, can you hear me?
Better now.
Okay, I'll yell. The term that's used in the document, but I don't know that I heard it here in this for the aggregate assessment, is the word less certain. Can you help me understand what that means for non-cancer risk, less certain? Okay.
This is Susanna Wegner. Can you refresh my memory where the context is, where that term is coming in?
It's in unreasonable risk determinations for consumers and in indoor air. But I didn't know, we're talking about aggregate, but it's two of the pathways. And then there's a term that's used, which is you identify some non-cancer risks as less certain. And I didn't know if that weighed into your qualitative analysis or not?
So thanks for the question, Anna Lowett. As we discussed earlier in the day, the risk determination portion of the risk evaluation is outside of scope of the SACC meeting. We're not asking any questions about the risk determination. A lot of policy goes into those determinations. And it's up for revision pending this meeting and updates to our assessment. So that we ask that we stay within the science bounds and not the risk mitigation bounds.
Okay, I'll ask another question, which may also be in that realm, and that's the margin of exposure, right? If we're looking at aggregating or even individual exposure pathways, is the margin of exposure in the allowable questions or not the allowable questions?
Well, can you ask a question?
I can. I can ask a question. The use of a margin of exposure, right, assumes that, or can assume that this, I'll call it the background exposures, the background concentrations that EPA considered in the ambient air and in the air pathways creates a calculated exposure and compares to something. Is that something the background that includes for example, the oil and gas generated formaldehyde? I'll ask it a different way. The margin of exposure approach has been questioned in previous SACC meetings. Is the margin of exposure still a metric that EPA is using in this analysis? And is that the policy part, or is that the science part?
Okay, so I'll take the second part of that.
All right.
So a margin of exposure is essentially just a ratio, as you know. It's a comparison of hazard and exposure using a benchmark that's historically in most assessments, some combination thereof of the extrapolation or the uncertainty factors. Mm-hmm. As you're hinting at in your question, the interpretation of the MOE, of the margin of exposure, what we call an MOE, is challenging. It's challenging in part because of the things that we've talked about all day and related to our question, that we have a lot of technical questions around some of the hazard issues, particularly the application of the IRIS to our assessment. We have methods and data analysis questions around our exposure assessment. And those science issues really, we're looking forward to your comment to resolve those so that we ensure that the science analysis is refined and robust. The interpretation of the margins of exposure is also difficult in this case because there are natural sources of formaldehyde both in the home and the outside, which may be equal to, if not higher in some cases, than the TSCA COU exposures. Michal Friedhoff, our assistant administrator, likes to use the candle example. The candles actually emit quite a bit of formaldehyde, and the formaldehyde from a candle can actually exceed some of the off-gassing of other materials in the home. So it becomes difficult that, OPPT is not going to ban candles, right? And nor can we ban decaying organic matter. So it's a very challenging interpretation space. So our first and foremost request for this panel is to help us with our refinement of our science analysis, the methods and models that we're using, the data that we're using, the data analysis approach, the interpretation of those things, that really refining our assessment to make it robust will help us in a step in that direction. And that's really what we're asking all of you to do.
Thank you.
Great. Thank you for all the questions and the answers. We are at 4:30 Eastern, 3:30 Central, 2:30 Mountain, and 1:30 Pacific as I have it. So we're a fair amount behind schedule, but I think we'll have the EPA summary and wrap up, maybe followed by a few questions if folks have them, and then we will adjourn for the day. But we can have the summary and wrap up by Dr. Schiffler.
Thank you, Dr. Cobb. Jeff Morris is going to give a brief introduction here at the top, so I'm going to defer to him first.
Very nice. Thank you.
Yeah, this is Jeff Morris at EPA. Thank you very much for allowing me to introduce the end of day wrap up. The last discussion we had was extremely useful. And I wanted to just start our wrap up by reminding everyone, because it can get lost in all of the technical discussion, that the main purpose of our TSCA risk evaluations are to be decision support documents. And when we decide how to construct our analyses, one of the factors that goes into that is trying to develop risk estimates that we can actually use to support decisions that will allow us, primarily under Section 6 of TSCA, to take actions to mitigate risks. So make sure that workers are protected. Make sure that emissions that result from the use of formaldehyde are not problematic, of ensuring that any concentrations of chemicals in products subject to TSCA regulation can be controlled if necessary to reduce exposure to people who use those products. There are a lot of emissions of formaldehyde that were difficult for us to contextualize in that space because they don't necessarily lend themselves to direct regulation under TSCA. So as you help us move this evaluation from draft to final, I just wanted to point out that one of the series of choices that we have to make is to decide which parts of the big formaldehyde space we can evaluate and develop risk estimates around that can support agency decision making, primarily in the TSCA space. But to the extent also that the evaluation can inform other decision making, then we welcome your comments on that as well. But I just thought that the last discussion really lent itself to explaining the role that the TSCA evaluations play in our decision making. So with that, I'll turn it over to Sean for a wrap up. Thanks.
Yes, thank you.
All right, thank you, everyone. This is going to be a shorter presentation of the presentations we've seen today. I do want to thank everyone for their time and attention. We have just a few slides. Dr. Anna Lowett and Dr. Rochelle Bahati are also here to help make any clarifications as needed to reorient everyone. If I can advance this, thank you. So as we mentioned at the top of this meeting today, the risk evaluation is the primary decision support document. As such, understanding the subject chemical is important in considering how that chemical will be managed in terms of any identified risks. That's the expectation for the risk evaluation. That is, our risk evaluations need to be fit for purpose. Spending a lot of time and effort to do analyses that may not be used by risk managers or is not needed to support a decision is not necessarily an effective use of our resources. I want to reiterate that our risk evaluations are not research papers. They are regulatory documents with very defined purposes. The US EPA must complete risk evaluations within 3 years. This time includes not only the completion of the risk evaluation, but it also includes peer review and multiple public comment periods along with the completion of the risk determination. This means the actual time to complete the science aspects of the risk evaluation is short. As such, the methods approaches you are being asked to review must be adequate to derive risk estimates sufficiently robust to support any unreasonable risk determination and subsequent rulemaking, as well as be feasible to complete within the necessary timeframe. The development of an individual risk evaluation, as well as the overall risk evaluation process, is incremental and iterative. We learn from each risk evaluation and modify and further develop new assessment methods and approaches to improve TSCA risk evaluations moving forward. However, as I mentioned before, we must use the information that we have available at the time we are completing the risk evaluation. Any information we receive past that defined point in time can help us with future evaluations or method development. Next slide, please. I'll remind you, as part of the TSCA risk evaluation process, assessors consider the conditions of use in context of the relevant exposure source. For example, articles and products such as consumer goods or releases from industrial facilities, either to air, land, or water. And then based on this information, the assessor considers the pathway of exposure, whether that be air, land, or surface water as examples. And then from there, the assessor will estimate concentrations in media and how organisms will be exposed and the route by which they are exposed. Next slide. And so over the course of today, we've talked about occupational exposures, consumer exposures, indoor air exposures, aggregate exposures, potential exposures from land and water and pathways. And we just want to kind of conclude by finalizing that this particular risk evaluation has many parts, and we are very thankful to all those who have been able to contribute in the process of developing the risk evaluation and reviewing it. And so with that, I want to thank TAMU and all the folks that are in PREB. I also want to thank the formaldehyde risk evaluation team and all those who have had to review and work to get it to its completion. And with that, I can take any clarifying questions.
Thank you. Let's see if there are any questions from the committee. Seeing none, we may be close to the end of our meeting. If we're close to the end, first of all, I would like to say thank you to all of the EPA presenters. I know it's been a long day for you folks. You've kind of in the, lack of a better term, been on the hot seat all day, and I appreciate you entertaining our questions and the dialogue. This is very complex for us. I know it has been very complex for you over the last several years. We're kind of playing catch up in some ways, and I thank you for bearing with us and getting all of these questions answered. I look forward to hearing from the public tomorrow and then jumping into the charge questions when we're able. I'd like to thank the committee for a robust discussion today. Very good questions, and the public for hanging in there with us to observe what we're evaluating here. That's all that I have. I would like to turn it over to Ms. Gibson now as our designated federal official.
Okay, great, wonderful. And I too would also like to thank the agency for their technical presentation, my colleagues in the peer review and ethics branch, as well as the committee and the public for listening in. I also want to announce that the public commenting session will begin tomorrow morning, approximately 10:20. So you have been contacted by our contractor to arrive at a certain time. So you will receive another email from our contractor between sometime later this evening or tomorrow morning for your link. So be prepared for your public to make your public comment tomorrow. Again, thank you all for participating. If there aren't any other questions, we'll see you tomorrow. The meeting begins at 9 a.m. Eastern Standard Time, and have a good evening. And today's meeting has been adjourned.
Thank you.
Tammy, just a quick clarification. Does the meeting start at 9 a.m. Eastern Standard Time tomorrow or 10 a.m. Eastern Standard Time?
Did I say 9? I'm sorry. Did I state?
You said 9.
I apologize. I was thinking 10 o'clock. It's 10 o'clock tomorrow. I apologize. Thank you.
It's been a long
10
day for all.
a.m. Yes, Eastern. I apologize for that.
Yeah, 9 Central.
Yes.
8 Mountain and 7 Pacific.
To go eat.
So I will also
Okay,
just,
all right.
before we close up, I'll say we will start tomorrow's session with any questions that have somehow didn't get answered or asked today. I'll just recycle back and ask if there are any questions that have cropped up since and that'll probably get us to the 10:20 time point. And that's all I have to say for today.
Okay, thank you. The meeting has been adjourned. Thank you.
Thank you. Bye-bye.
Good day.